the night before November 4. No big announcements, no headlines, just a quiet ripple moving through small observatories, encrypted groups, and a handful of astronomers who don't sleep much anymore. Amateur frames start surfacing from the Atacama, raw and grainy but alive, and there it is again. A brightness spike where the comet shouldn't flare. Not dramatic, not cinematic, but wrong enough to pull you forward in your chair. The kind of wrong that gets buried in comment sections until it doesn't. For months, 3I, Atlas, has behaved like something ancient passing through our system for the first and last time. But tonight, that simplicity cracks. A faint streak appears in one high-altitude capture, barely visible unless you know where to look. The watchers pause, zooming, adjusting contrast, comparing frame after frame. One calls it an artifact, another says the jet's misaligned. Someone else swears it twisted, yet none of them agree. The silence in the official channels feels heavier than noise. ESA has been calm, NASA is monitoring, and everyone else is pretending this is routine. Routine objects don't get live monitoring chains, and instrument warm-up schedules whispered on internal boards. Then, right before dawn, one obscure radio group posts a line in their log, a narrow anomaly near the noise floor. Nothing dramatic, just consistent. Almost too consistent. Not a signal claim, just a data point. But the people who have followed every interstellar visitor since Oumuamua remember how the last spike never happened after the press offices got involved. Calibration error, they said. Data misinterpretation. Everyone moved on, except a few who didn't. Now ESA's juice is hours away from aligning sensors toward 3I, Atlas. Magis, Janus, SWI instruments designed to study moons are quietly being aimed at an object that shouldn't exist in our neighborhood for another 100,000 years. Official schedule, magnetospheric studies, unofficial chatter, final checks, temporary allocation shift, external transient tracking mode. They don't call it target lock, but it feels like target lock. So, we wait. Not for a press release, not for a big reveal, just for the moment when a European probe orbiting Jupiter turns slightly, stabilizes, and looks out into the dark at something older than Earth's crust. If this object is just a comet, tomorrow brings numbers, spectra, dust composition. But if it isn't, then tonight may be the last quiet night before a very different kind of story begins. You can feel it, that thin line between science and silence, where discoveries don't get announced, they get managed. And tomorrow, we find out which side 3I, Atlas, belongs to. If you want to stay ahead of the official story, subscribe and turn on notifications. Drop a comment with your location and local time. I want to know who's still awake out there, waiting for Juice to look up. In the official mission timeline, November 4 isn't supposed to be special. Juice is in its long cruise around Jupiter, calibrating instruments, mapping the radiation environment, planning its long dance toward Ganymede. No press briefings, no excitement. Just routine science in deep space. But if you've been following the internal scheduling notes, the sudden chatter in certain ESA subchannels, and the timing of last-minute thermal stabilization cycles, you know better. NASA might not say anything. ESA will pretend this is just a magnetospheric cross-check. But deep in the engineering logs, the spacecraft attitude control entries tell the real story. Pointing shift requested, tracking stability priority increased, exposure routines preloaded. That doesn't happen unless something matters. And think about this, since Oumuamua and 2I, Borisov, every interstellar object has slipped past us with our best instruments pointed the wrong way. This time, for the first time in history, we have a flagship science probe already on station, already powered, already steady, with cameras and spectrometers capable of analyzing surface ice composition and thermal anomalies from an object that shouldn't be here. They can call it coincidence. They can call it opportunistic observation. But the timing feels engineered. Like someone, somewhere inside ESA, decided this was the moment to quietly flip a switch and listen harder. Because right now, 3I, Atlas, is still doing things a normal comet shouldn't do. The brightness curve doesn't match conventional sublimation models. Amateur photometry suggests rotational behavior that can't quite decide if it's tumbling or adjusting. The dust tail bends at angles the standard solar wind models can explain, until you realize the bend changes when it shouldn't. And don't forget the perihelion quiet period. 8 days. No updates. Every major instrument supposedly offline for solar interference mitigation. Plausible. Sensible. Except when Mars orbiters later reported they had continued imaging operations without interruption. Too many coincidences stack up, and eventually even the most skeptical among us starts asking whether this silence is just noise or deliberate signal suppression. JUICE wasn't built for comets. It's a Jovian system explorer, a moon hunter, a plasma observer, but it has eyes capable of precision surface imaging, spectrometers tuned to identify complex volatiles, and plasma sensors that can detect unnatural electromagnetic signatures. If 3I Atlas were nothing more than a dusty relic drifting from another star, JUICE would give us a bonus chemistry profile and everyone would go home happy. But if it's more, if it carries compounds that don't match known cometary families, if the coma is emitting structured spectral lines, if the thermal map shows heat where there should only be cold starlight and solar scattering, then tomorrow becomes historic. And there's one more thing nobody's admitting publicly: the orbital geometry. 3I Atlas is passing in a window where Jupiter's magnetosphere is acting like a natural detector. Plasma sheaths, radio bursts, magnetotail perturbations, these aren't random noise out here. It already has sensors warmed and tuned for subtle charge gradients. ESA calls it radiation belt characterization. Convenient, almost elegant. A perfect cover for testing whether an incoming interstellar body responds to electromagnetic environments in ways ice and dust shouldn't. The community knows something is coming. The nothing to see here tone feels too polished, too calm. And the insiders, the ones who always speak in carefully vague fragments, keep posting the same line. Data window 9/5012 to 20 UTC. Watch for the telemetry gap. They never say why. They don't need to. People who have watched space agencies play this game for decades recognize the pattern. Something will be seen. Something will be processed. And the first version of that, something will not be public. So here we are, counting down to a moment nobody asked permission to care about. A European probe adjusting its gaze, the scientific community acting like this is routine maintenance, and a silent traveler from outside our solar system sliding through a detection corridor like it was meant for this. Maybe it's nothing. Maybe by tomorrow afternoon we'll laugh about the excitement and move on to the next James Webb Galaxy release or lunar dust study. But part of you knows this isn't that kind of night. There is a different energy here, quiet, heavy, expectant, like the world is holding its breath without knowing why. Tomorrow, JUICE looks at 3I Atlas. The first controlled, instrumented stare humanity has ever taken into the path of an interstellar wanderer. And if history has taught us anything, it's this. When space agencies go silent first and observe second, the universe tends to answer in ways we are never fully prepared for. When JUICE launched, nobody at ESA stood on stage and said, "By the way, this spacecraft might one day be our first interstellar watchdog." It wasn't in the brochures. It wasn't in the press kits. JUICE was branded as a mission of moons, Europa's chemistry, Callisto's history, Ganymede's magnetic heart, pure planetary science, pure bureaucracy-approved exploration. Yet here we are, barely a year into cruise operations around Jupiter, and suddenly this quiet European probe has drifted into a role no mission team dared plan on paper. Guardian of the outer system, silent sentinel, forced by circumstance and orbital mechanics to be humanity's front-row observer of something from beyond our Sunday. Most people don't understand the significance of location in space. It's not just distance, it's geometry, shielding, plasma environment, line of sight stability. Earth can't watch 3I Atlas properly right now. Ground telescopes fight solar angle. Mars orbiters saw something, then lost it behind interference windows. Even JWST has struggled to maintain optimal pointing windows. But JUICE? Perfect position. A stable gravitational perch near the most powerful magnetic field in the solar system. Radio wave clarity. Plasma sensitivity. Instruments originally meant to decode moon crusts and icy subsurfaces, now pointed, quietly, at a target no one publicly acknowledges as priority. And here's the thing. Deep space probes don't just reassign observation schedules. That's not a two-click command. It's committees, review boards, flight dynamics verification, or at least it's supposed to be. Yet, the internal timing of this retargeting, traced through telemetry watches and mission ops breadcrumbs, suggests agility, almost like somebody already had contingency protocols ready. Like someone knew we might one day need to point an outer system probe, not at a moon or a ring or a plasma cavity, but at a visitor. And as 3I, Atlas, crosses Jupiter's magnetic boundary region, that turbulent frontier where charged particles get sorted, accelerated, screened, JUICE becomes more than a camera. It becomes a filter, a sensor watching how this object behaves when exposed to a planetary magnetosphere on a scale Earth cannot produce. Does the coma react in expected ionization patterns? Does its plasma wake behave like dust and gas? Or does it hold structure? Those are real scientific questions. They are also, quietly, the same questions you might ask if you were checking whether something natural is truly natural. ESA will never phrase it that way. They'll say, material response under variable magnetohydrodynamic conditions. But the subtext writes itself. Engineered objects don't just move through magnetic fields. They interact with them. And the mission team knows that if anything unusual happens, even the slightest deviation from standard comet behavior, it won't be loud. It won't be dramatic. It will be subtle. A frequency spike. A dust emission rhythm that matches a harmonic pattern instead of thermal outgassing randomness. A plasma tail that aligns harder than it drifts. These aren't Hollywood-scale anomalies. They're quiet, mechanical hints. Tells. Behaviors nature doesn't favor often, but intelligence might. Right now, official feeds are calm, nominal operations, routine housekeeping, systems stable. Meanwhile, independent spectral logs keep lighting up forums with confused notes. CN bands sharper than expected, possible CO2 overabundance. An albedo shift someone claims isn't a processing artifact. Most people scroll past, waiting for sensational headlines. But the watchers know. Real anomalies don't erupt. They accumulate. So now we have a Jovian-class science probe facing an interstellar body in the most sensitive electromagnetic theater in the solar system, and not a single agency wants to acknowledge how unprecedented this alignment really is. You can call it coincidence. You can call it a lucky accident of orbital timing and discovery. But more and more, it feels like a quiet test, a moment where the universe brings visitors to our doorstep and, for once, we're not blinking, because if 3I, Atlas, is just ice and dust, JUICE will prove it. But if it isn't, if there's even a whisper of something structured, intentional, or mechanically behaved, then in the outer dark around Jupiter, far from press rooms and public streams, humanity already has a witness. A silent spy in the perfect place to see the truth before anyone else. Janus was never supposed to be a comet hunter. Its design brief is public, a high-resolution optical camera meant to map icy moon surfaces, trace fissures, catalog impact basins, identify cryovolcanic scars, craters, ridges, fractures, things you'd expect on Ganymede or Europa. But when ESA quietly retuned Janus pointing parameters, nobody issued a press note saying why. Buried in the ops logs, non-lunar target mode validation. That phrasing alone tells you someone anticipated, pointing it at something not in the brochure. The big question is, what exactly does Janus expect to see in the coma of 3I? Atlas. The official academic line about comets is simple. Sublimating volatiles, chaotic dust outflows, jets that follow thermal differentials. Nothing consistent, nothing geometric. Nature loves randomness. The coma should look like noise with occasional structure driven by heat. But amateur stacks from last week, processed by people who live for pixel-level truth show threads. Not solid lines, not proof, just hints. Filaments that seem to hold alignment longer than thermal jets should. These get dismissed fast. Compression artifacts, registration errors, stacking jitter. Except when multiple observers in multiple hemispheres get the same thing on the same night with similar angular deviations. That's when artifact starts sounding like a reflex rather than an explanation. NASA isn't commenting. ESA isn't either. But everyone remembers how Oumuamua's light curve and acceleration were probably natural, even as the papers kept adding footnotes. Non-gravitational acceleration not fully understood. Shape unconstrained. Spin state ambiguous. It's always the footnotes that matter. And here we are again, independent images, hinting at persistent geometry in a coma too young and too active to sustain crystalline dust patterns. If Janus finds repeating structure, coherent filaments, consistent angular jets, rotational symmetry, then we move from comet behavior into non-random behavior. Subtle difference, massive implications. Here's where it gets interesting. Janus isn't just looking at brightness. It can track motion frame to frame, identify repeating emission patterns, detect if dust outflows modulate at the same rotational frequency, or worse, if they don't match rotation at all. Because natural rotation-driven jets behave like clockwork, but if something adjusts, if a pattern shifts, like a controlled exhaust instead of a thermal vent, then you get the kind of anomaly scientists don't announce until they've argued for months behind closed doors. And don't forget the timing. 3I Atlas just cleared perihelion. Thermal stress should be maximum chaos right now. Jets firing irregularly, coma expanding wildly, dust shedding in unpredictable plumes. Instead, some reports suggest stabilization, a narrowing of the coma, reduced randomness where maximum disorder should exist, not impossible, just unusual. And that's how every major anomaly arrives, not with impossibility, but with quiet inconvenience to accepted models. To be clear, nobody sane is claiming structure equals intelligence. The universe has ways of surprising us without aliens. Crystal grains can align, jets can appear patterned, plasma interactions can mimic geometry. But Janus has one job now, to make those distinctions sharp. If it finds random spray, this mystery fades. If it finds traces of repeating angles, if brightness oscillations lock to frequency, if dust outflow appears modulated rather than chaotic, then all those whispers about engineered behavior move from fringe speculation to cautious academic footnotes. And once footnotes arrive, headlines are never far behind. In the coming hours, Janus isn't hunting proof, it's hunting deviations, small ones, tiny ones. The kind that makes scientists stare longer at screens and double-check calibration files twice before sending an email they know could redefine the conversation. When we get the first processed frames, the raw images won't tell the story. The hesitation in analyst comments will. Tomorrow, if things line up the way the quiet corners of the internet expect, we won't ask whether the coma looks natural. We'll ask a more unsettling question. Why does an object from another star system look like it's hiding order inside chaos? Magis doesn't care about pretty pictures. It cares about truth in wavelengths. Built to dissect the surfaces of icy moons, it reads light the way a forensic analyst reads fingerprints, not for beauty, but for origin. Water ice, radiolytic residues, organic compounds broken by Jupiter's storms. Every spectrum tells a story. And now that same instrument is quietly turning toward 3I Atlas, looking not for craters or frost, but for color signatures that shouldn't be there. Comets announce themselves chemically. CN bands, OH emissions, COH plumes. Their light betrays their age, their birthplace, their temperature history. But the first whisper from early spectral watchers was unsettling. 3I Atlas didn't behave like a solar system comet. Too much COU relative to water. Emission ratios you don't see in our backyard. Strangely blue photometric behavior in certain bands. Unusual scatter at longer wavelengths. These aren't dramatic anomalies. They're quiet ones, the kind that slip into scientific preprints as unexpected features warranting further study. We've seen that language before. It's academic for "this doesn't fit, and we don't know why yet." ESA hasn't said a word. NASA keeps using phrasing like preliminary evaluation, as if everyone is politely waiting for someone else to blink first. Meanwhile, the amateur community has already done the math. They've run color index comparisons against known comet classes, and every time they post results, the comments fill with the same uncomfortable suggestion: this thing came from a chemical environment we don't understand. Maybe colder. Maybe older. Maybe processed differently by cosmic rays in a region no solar system object has ever lived in. That alone would be historic. A chemical fingerprint from a star system, not our own. But there's a more fragile possibility tucked in the background. What if some of the observed spectral stability isn't natural? What if something on or within the object maintains certain surface materials or thermal patterns in a way nature doesn't prefer? Nobody credible is shouting that. No aliens confirmed. Just quiet discomfort. Because the spectrum is where nature usually tells the truth, and when the spectrum hesitates, scientists do too. MAGIS will run full sweeps. Near-infrared absorption bands, reflectance gradients, thermal emission signatures. If the surface is normal, we'll see typical volatiles and dust signatures, maybe spiked with exotic interstellar chemistry. But if MAGIS picks up structured absorptions, anomalous thermal pockets, or compounds that shouldn't survive a star pass intact, everything changes. Even a hint of artificial coatings or composite-like reflectance patterns would send mission teams into lockdown mode faster than any press office could draft a statement. There's also a timing element nobody mentions directly. 3I Atlas just past perihelion. Radiation bombardment, thermal shock, the surface should be raw, chaotic, shedding material. Perfect time to catch fresh substrate, unweathered compounds. Most comets look messy and unpredictable right now. But if MAGIS sees stability where chaos should dominate, if certain spectral features appear too clean, too consistent, then the question becomes unavoidable. Is this object enduring perihelion or managing it? And remember, the last time astronomers saw strange spectral behavior in an interstellar object, we spent 5 years arguing about Oumuamua's physics. Hydrogen sublimation models, exotic fractal dust, light sail speculation tucked into respectable journals. Nobody wants that fight again. Not without data, not without proof. That's why MAGIS matters so much here. It can give us the first hard evidence, one way or another. Soon, we'll know if 3I Atlas is just ancient ice singing an alien chemical history or something more curated. Something with surface chemistry that didn't just happen, but holds. And when that first process spectrum hits labs, even if the public never sees the raw file, the analysts will know within minutes whether we're dealing with a relic of cosmic formation or a visitor wearing a mask of ice. SWY wasn't built for drama. It's a sub-millimeter wave instrument, the kind of tool only scientists with patience and insomnia brag about. Its job? Sense faint heat and gas signatures, tease out molecular fingerprints in frozen moons and thin atmospheres. It looks for temperature profiles, thermal irregularities, the soft hum of physics doing what physics does. Which is exactly why its role here feels so quietly dangerous. Because comets at this distance aren't supposed to hum at all, they should barely whisper. At 1.3 AU past the Sun and moving outbound, 3I Atlas should already be cooling rapidly, bleeding heat into space like every natural object does after perihelion. Thermal decay curves are predictable, boring even. But the early temperature estimates, the ones buried in discussion threads and could be calibration noise, comments, don't look boring. Some observers flagged localized thermal persistence. Translation, parts of the object didn't cool as fast as they should have. That's the kind of detail most people scroll past. They don't realize how unnatural it would be for isolated thermal pockets to remain stable without continuous input or insulated mass beneath the surface. Comets don't have heaters. They don't regulate temperature. They flare and fade, predictably, violently, messily. Yet the whispers keep coming. Thermal anomalies too subtle to headline, too persistent to ignore. ESA says nothing. NASA sidesteps the question. And independent analysts keep circling back to the same uncomfortable possibility. Either the nucleus is incredibly dense with exotic ices that hold heat far more efficiently than expected, or something inside isn't passive. SWI is about to put that speculation to the test. Sub-millimeter emissions tell the truth even when visible light misleads. Heat doesn't lie, not at this scale. If 3I Lass cools like a rock, we close one chapter. If it radiates unevenly, if pockets stay warm, if thermal bands don't match natural outgassing, then we're looking at controlled heat retention, layered compositional structure, or internal mechanisms we don't yet understand. And internal heat on an interstellar visitor is the kind of phrase that turns conference rooms silent. Nobody in the agencies will say this out loud, but here's what really keeps researchers awake tonight. Outgassing patterns can mimic thrust. Thermal asymmetry can mimic attitude control. And heat signatures that plateau instead of plummet. That's not comet behavior, that's system behavior. Even if the explanation ends up natural, SWI is the first real audit. It reads the object like a thermal lie detector. If the coma cools uniformly and the core fades into the deep cold of interstellar exile, we move on. If SWI finds pockets of heat where physics says none should remain, then the narrative shifts from curiosity to suspicion, from wanderer to potential craft. Nobody's ready to say that word yet, but instruments don't care about comfort, they read reality. And when SWI's plots stream back to Earth, even if the public sees nothing but a filtered press comment and a jargon-thick PDF, the people inside the data rooms will know within minutes whether this object simply survived the sun or prepared for it. RIME was designed to see beneath ice, not skim past it. It was built to fire radio pulses into the crusts of Europa and Ganymede, peel back layers of frozen history and map structures buried kilometers deep. Subsurface oceans, ancient fractures, pockets of brine, that's its language, which makes its quiet retasking here almost absurd on paper. Radar soundings on a fast-moving, faint coma interstellar object. Nobody puts that in a mission proposal. Too risky, too unpredictable, too easy to justify as not worth the bandwidth. And yet, tucked into ESA's internal activity logs, there it is. A brief testing window marked with just enough ambiguity to keep deniability intact. Low-gain subsurface trial on transient body. Not a moon, not a known target. A transient body. You don't radar probe a transient body unless you think there's something to find. And here's where it gets uncomfortable. Comets don't want to be seen inside. Their interiors are chaotic, porous, layered with aeons of frozen randomness. Radar scatters, signal collapses, returns smear into noise. Oumuamua would have been the same if we'd had a radar instrument anywhere near it. But 3I Atlas? Its early coma behavior didn't scream fluffy rubble pile. Too stable, too consistent. Even now, after perihelion, the fading pattern lacks the irregular fragmentation spikes we expect. Some researchers whisper it's denser than anticipated. Others say the opposite, unnervingly uniform, like it's built, not accumulated. RIME's pulse will tell the truth faster than any press release ever will. If the signal scatters wildly, we get the standard answer. frozen chaos, no surprises. But if there's a coherent return, even faint, even fragmented, that's not comet behavior. That's structure, layers, cavities, reinforcement. And if the radar echo reveals symmetry, a repeating depth pattern, hollow regions too geometrically clean to result from natural sublimation, then the debate changes forever. ESA will never phrase it that way publicly. They'll say interpreting anomalous radar profiles requires careful modelling. We've heard that language around Venus phosphine, around Tabby's star, around Oumuamua's acceleration, polite scientific caution masking something heavier beneath the surface. And yet the risk here is real. If 3I Atlas is just ancient ice and dust held together by time and luck, Rime's ping might break nothing but hope, returning nothing but static. But if Rime finds internal voids, hard shells, stratified bands thicker than any comet core model predicts, the analysts in Darmstadt will freeze, not from fear of aliens, but from the weight of being first to see inside an interstellar traveller. To know, silently, before the world even suspects, whether this thing formed the way comets form, or whether something once carved space for itself inside. Nobody expects a perfect blueprint. Radar doesn't give shapes, it gives hints, the kind that trigger classified phone calls and closed-door workshops. But tonight, just before the pulse goes out, there's a strange tension across the small corners of the internet where people still watch telemetry like others watch sports. Because if a radar echo from a visitor beyond our sun comes back sharper than noise, even a single clean spike, we'll have to ask a question humanity has never asked with data in hand. What if this object isn't empty by accident? 3GM is the kind of instrument nobody outside mission architecture talks about. No viral headlines, no cinematic visuals, just gravity, radio links, and math sharp enough to peel open the universe. Officially, it measures Ganymede's gravity field, internal mass distribution, and subtle shifts in spacecraft motion. Quiet science, precise science. But the elegance of 3GM is simple. Anything with mass leaves fingerprints in space-time. Everything tugs, everything bends radio waves. And when you apply 3GM logic to an interstellar object passing through a planetary gravity well, you aren't just observing it, you're weighing it. That matters more than most people realize. Comets follow gravity like sheep follow fences. They arc, they curve, they bend the way Newton says they should. But if there's even a whisper of non-gravitational influence, outgassing that behaves too efficiently, acceleration that lines up too cleanly, a trajectory curve that stays too smooth after perihelion when randomness should be creeping in, then mass models start to flicker. Oumuamua forced that conversation. Tiny accelerations, too neat to ignore. We blamed hydrogen sublimation, radiation pressure, exotic fractal geometry, anything to keep the word controlled out of the room. With 3 Atlas, we don't have to guess. We have a gravity probe nearby. 3GM will watch the slight disturbances in radio frequency returns, subtle Doppler shifts, micro nudges in Jitus motion. Think of it as a scale in deep space, but one so sensitive it can tell if a grain of dust leans left instead of right. If 3I Atlas has the mass profile of a natural body, irregular, fractal, inconsistent, 3GM will see the expected jitter and drift in the gravity field as it passes through Jupiter's influence. But if the mass signature is cleaner than expected, more uniform or worse, lighter than its size should allow, then we face the same uncomfortable implication that made scientists squirm during the Oumuamua papers. What if this object's density isn't natural? Low density could mean a fluffy comet nucleus, or it could mean hollow structure. Unexpected uniformity could indicate compressed exotic ices or layered internal architecture. A mass-to-shape mismatch isn't proof, it's a question, one that forces another. Why would an object traveling between stars have internal voids? Why does its gravitational behavior match the models too well or not well enough? And why, for the second time in a decade, are we quietly asking whether mass anomalies point to something engineered? ESA will deny their testing for this, just like they denied navigation filters were ever applied to Oumuamua for non-standard trajectory modeling. But telemetry watchers already know flight dynamics teams are monitoring perturbation logs in real time. Gravity isn't dramatic. It doesn't roar or flash or leave trails in the sky. It whispers. And when the whisper doesn't match expectation, smart people stop sleeping. If 3GM returns normal gravitational signatures, this story becomes chemical, not structural. But if the numbers slip, even by a fraction, then suddenly every anomaly we've seen so far stops being isolated and becomes a pattern. And patterns in science always lead somewhere, sometimes to new physics, sometimes to new fears, sometimes to the quiet acknowledgement that nature didn't build everything that passes by our star. When that first internal mass estimate lands on a protected server, a few analysts in Europe will know before the rest of the planet whether 3I Atlas is a chunk of frozen interstellar debris or a shell with secrets inside. They won't say it aloud. Not yet. They'll use phrases like unexpected density gradient and inconclusive gravitational return. But behind those words lies the real question drifting through every scientist's mind tonight. What do you call an interstellar object that weighs less or more than physics says it should? PEP doesn't look at anything. It tastes the invisible. Ion flux, charged particles, composition of plasma streams, the electrical scent trail of space itself. Around Jupiter, it was meant to decode the dance between magnetosphere and moon, a laboratory for understanding charged environments. But turned toward 3I Atlas, it becomes something else entirely. The first instrument in human history capable of sampling the plasma wake of an interstellar traveler from inside a planetary magnetosphere. That's not a research milestone, that's a line in the cosmic sand. Comets bleed ions under solar pressure. Their tails aren't just dust, they're electrical signatures, ionized gases stripped and flung by starfire. And normally, those signatures follow patterns we understand. Water group ions. Carbon species. Solar ion pickup consistent with known chemistry. But early amateur spectroscopy and scattered radio logs hinted at something else trailing 3I Atlas. Unexpected ion densities, weird charge behavior, and, if the fringe telemetry whispers are even partly real, a hint of periodic modulation in the ion tail. That word periodic sits like a splinter. Natural, possibly. Convenient, no. And now PAP has a front row seat. Here's why this matters. Jupiter's magnetosphere is a plasma crucible. It stretches farther than the Sun itself, a giant cage of charged particles, radiation belts, and magnetic shear currents. When something enters it, we see what it's really made of. Natural bodies get shredded, ionized, buffeted into submission. Their wakes become turbulence maps. But engineered objects, their response would be different. You'd see ion shielding, jet-like ion release, noise suppression patterns. Subtle coherence in charged particle distribution where chaos should reign. Not a Hollywood force field, just anomalies. The kind that force mission teams to minimize comms chatter and start cross-checking with classified magnetosphere models. Nobody in an agency will ever say, "We're checking if it's shielding itself." Instead, you'll hear phrases like characterizing solar wind coupling efficiency. But Behind that language is the truth that plasma doesn't just reveal composition, it reveals intent. If 3I Atlas interacts with Jupiter's magnetic field in purely natural ways, PEP will see classic ion escape patterns, fluctuating charge distributions, and a tail that dissolves into the Jovian plasma sea. If it doesn't, if the ion ratios stabilize, if the plasma wake narrows instead of dispersing, if charge gradients lock to rotation or, uncomfortably, defy it, then the story changes, quietly at first, then violently across academic circles. There's also the question most won't ask yet. Why did ESA approve PEP sampling on a non-mission target with no public science justification? That kind of deviation needs signatures, risk clearance, bandwidth allocation. Someone signed off on this, someone high enough that no one argues, which means someone, somewhere, thinks the plasma profile of 3I Atlas is worth knowing before anyone else sees the full picture. If PEP detects exotic ion ratios, noble gas enrichment, trace metals in unexpected states, organized charge stratification, it won't leak immediately. It'll slip into internal memos, go through data validation cycles, and then emerge months later watered down, wrapped in caveats. Meanwhile, the first analysts to touch the raw telemetry will stare at their screens, knowing something that the rest of humanity doesn't, whether the first object confirmed to have visited us from another star behaves like frozen nature, or like something that knew it would cross into ours. Because plasma is the frontier where the universe stops lying, and if 3I Atlas has secrets, the ion trail is where they start to slip. The question now isn't whether PEP finds something weird, it's whether anyone outside a sealed room ever hears about it. Every interstellar object so far has come with a problem. Oumuamua accelerated when it shouldn't have. 2I Borisov fragmented cleaner than expected. And 3I Lars? From the very start, its trajectory has carried that same faint smell of almost natural. On paper, it behaves, mostly like a comet, hyperbolic orbit, inbound, swing around the sun, outbound escape, textbook, perfect for slides in astronomy classes. But the deeper you go into the data logs, the more little wrinkles you find. Nothing flashy enough to headline, but enough to bother precision minds. Slight coarse smoothness where thermal outgassing should introduce wobble. Rotational evolution that feels too controlled before perihelion, then suspiciously stable after. And a mild but persistent tension between amateur astrometry and institutional orbital fits, explained as processing variance. People forget that phrase appeared in early Oumuamua files too. Trajectory isn't just position. Its personality. A natural body arriving from deep space should carry scars of randomness, chaotic spin state, shifting outgassing vectors, unpredictable microjets near perihelion. Chaos is the signature of nature. But 3I Atlas keeps trending toward clean behavior. It had every opportunity to misbehave during solar approach, when radiation pressure and internal stresses break most icy visitors into tantrums of dust and torque. Instead, the reported anomalies faded into a kind of eerie composure, as if the object knew the worst was behind it and simply steadied. That's not proof of anything except discomfort. Yet in space science, discomfort is where revolutions begin. When JUICE performs its fine point tracking today, it won't just be looking, it will be measuring drift. Every micro-adjustment in the spacecraft's guidance software becomes data. If 3I Atlas exerts gravitational or radiative influence inconsistent with its visible mass, the numbers will show a quiet mismatch. Analysts call it residual error. Insiders call it the moment your stomach drops. Because if trajectory discrepancies survive post-processing, you don't get to hand-wave them anymore. You start running models with terms you hope to avoid: exotic mass distribution, outgassing asymmetry, non-gravitational propulsion. Nobody uses that last phrase officially. They call it unmodelled forces. But the implication hangs there, polite and poisonous. And here's the hidden layer. Trajectory anomalies are cumulative. They stack. One small deviation means nothing. But persistence, pattern, even a tiny periodic correction like behavior. Suddenly, you're not measuring a comet, you're auditing a traveler. Think about how intelligence would hide in open space, not by moving dramatically, but by moving almost naturally. Matching what real comets do just closely enough to blend in. If you wanted to pass through a system without alerting its inhabitants, you wouldn't glide like a ship in a sci-fi film, you'd drift like ice. Of course, there are safer explanations. Cryogenic ices we don't fully understand. Internal topography influencing sublimation vents. Pressure pockets releasing in ways that mimic correction. But those explanations will only hold as long as the tracking residuals stay within comfort margins. If today's telemetry shows even a hint of systematic behavior, you'll see an interesting silence before the next routine mission update. Scientists hate coincidences in orbital mechanics. They tolerate them until the math refuses to yield. Then the tone shifts. Right now, flight dynamics teams aren't asking the public question, where is it going? They're asking the private one, is this object flying like it knows where it wants to go? And if that question feels too big, too dramatic, remember it's been asked before, first in whispers about nous moi, then in white paper footnotes written by people who don't use speculative language lightly. We will know soon whether 3I Atlas is simply coasting through our gravity well, obeying physics with ancient indifference, or whether something in its path looks suspiciously like decision-making. And if JICE's data shows the latter, then behind closed doors the real conversation begins, not about aliens, but about responsibility, about who gets to see the truth first, and about whether the universe is still as quiet as we pretend it is. Most people missed the Mars angle. It slid past news cycles, buried as a footnote in mission logs and half-translated observatory notes. But the timing is what matters. During the days leading up to perihelion, when 3I Atlas slipped behind the Sun from Earth's perspective, we lost the view. Completely reasonable. Solar interference, line-of-sight blackout, radio silence. Space agencies shrugged, called it unobservable window. Move on. Except Mars wasn't blind. Maven, Maro, and even the little UAE Hope probe had geometry we didn't. They could still see parts of the corridor where 3I Atlas passed. And what trickled out later, half-quoted in technical chatter, echoed by amateur data chasers, was unsettling. Brief telemetry mentions of anomalous coma behavior and unexplained brightness. Consistency at a point when it should have been violently unstable. Then suddenly, nothing. No follow-up observations, no clarifications. A couple of science communicators tried to poke for updates and got boilerplate. Instrument priority adjustments, solar interference precautions, data under review. Yet Maven's radiation logs spiked in the same window. MRO's imaging schedule quietly shifted. And Hope? Silent. For a spacecraft that usually publishes every minor dust storm, that silence felt curated. You can explain away data gaps with solar geometry, but redacted logs and post-event reclassification tags, those tend to happen only when someone saw something unexpected and had to decide very quickly how to file it. Officially, Mars missions weren't observing 3I Atlas. They'll repeat that phrase if pressed. But there are amateur analysts who track spacecraft pointing vectors from publicly available telemetry, and they noticed orientation adjustments, that didn't align with scheduled atmospheric studies. Coincidence? Possibly. But coincidences in spaceflight tend to evaporate under scrutiny. And yet, here we sit, with 3 orbiters positioned perfectly to witness something we didn't, and all 3 acting like the moment never happened. This wouldn't matter if the object behaved normally after perihelion, but it didn't. Its brightness curve didn't collapse the way models predicted. The rotational data didn't wander into chaotic dispersion. Instead, we got stabilization, a quiet settling after a moment when unpredictability should have peaked. It's like watching a storm hit a ship and expecting shredded sails, only to see the vessel glide through perfectly trimmed a moment later. Not proof of control, just the uncomfortable illusion of it. There's a simple explanation the cautious scientists lean on. Interstellar comets may behave differently. Unknown chemistry, unfamiliar thermal inertia, exotic volatiles. And all of that is likely true. But here's the part nobody likes to say out loud. If Mars-based assets did see something unusual, a structured plume, a rotational correction, a thermal pulse, the protocol would be to bury that data until it's understood. Better silence than spark a panic or a premature theory war. We've been here before. When the phosphine signal surfaced on Venus, data releases slowed to a crawl. When Oumuamua didn't conform to Comet models, language suddenly shifted from certainty to unresolved mechanisms. Mars orbiters are workhorses, not spycraft. But they've seen things before that needed careful phrasing. If this was another one of those moments, the silence makes sense. Which leaves us with the most uncomfortable interpretation. Maybe someone on Mars did see the moment 3I Atlas steadied itself. Maybe the first place in the solar system to witness a possible correction or stabilization wasn't Earth. It was a fleet of silent observers circling a dead world. And now that Earth has the view again, Gyru ice is in position, and instruments are warming like stage lights before the main act. There's one question hanging unspoken in every analysis channel. What did Mars see that we aren't supposed to talk about yet? For 8 days the sky went quiet. Officially, it was just a solar conjunction window, routine blackout, nothing unusual, mission safety protocol. Spacecraft shut down non-essential operations, comms thin out, and Earth pretends patience is scientific discipline rather than necessity. We've been through this before, but this time the silence had weight, because during those 8 days, 3I Atlas rounded perihelion, the most critical phase. The moment when a true comet should erupt in chaos, shedding material unpredictably, wobbling, fracturing, screaming radiation into the dark as the sun tears at its skin. Instead, the data that trickled back after the blackout didn't match the script. No fragmentation signatures, no rotational noise spike, no violent coma turbulence archived for later release. Just continuity. Calm where there should have been crisis. And that's the part nobody can talk about too loudly. Because 8 days of silence is the perfect place to hide an answer. If 3I Atlas behaved unexpectedly at the sun, if its coma didn't boil the way textbooks demand, if its trajectory smoothed instead of scattering, if its thermal release stabilized rather than detonated, who would know? The public feed was dark. Institutional feeds were pending review. And every time someone asked for perihelion telemetry online, PR accounts repeated the same line, data scheduled for processing. That phrase has become a kind of cosmic red flag. It means someone already saw the raw stream and isn't ready to let anyone else touch it yet. There's a historical pattern here. When something conforms, data drops fast, press releases follow, mission Twitter accounts celebrate the incredible success. When something misbehaves, you get technical silence, then a curated dump weeks later. Look back at the Venus phosphine data. Look at the unexplained Mars methane spikes. Look at Oumuamua's post-fit trajectory notes, the ones that took months to finalize. Silence in space isn't absence, it's processing. And sometimes it's time bought to decide how to tell the story without rewriting the universe too abruptly. So what could matter enough to sit behind 8 days of sealed channels? Spectral stability at peak heating, tail geometry that didn't collapse, outgassing that looked organized instead of explosive. Or nothing exotic at all. Maybe just confirmation that interstellar ice behaves differently because the void writes chemistry we've never touched. But if it were that simple, the updates would be flowing already. Instead, the tone from official science accounts shifted subtly after conjunction, cooler, more measured, as if bracing for questions nobody wants to answer prematurely. And then came the strangest sign. The amateur community, usually loud after blackout windows, went unusually quiet, not because they saw nothing, but because they saw nothing wrong. No catastrophic breakup signatures, no wild rotational divergence. The comet came back into view like a machine clearing a checkpoint, smooth, predictable, almost eerie, natural, possibly, convenient, certainly. It's always the absence of noise that rings the loudest in space research. The universe is messy, chaotic, loud. Silence is rarely innocent. So the blackout passed, the data processed, and the object that should have been at its most unstable phase instead emerged looking more composed than before. The last time scientists saw that kind of behavior, it took 5 years and 24 papers for everyone to admit they were still confused. Now JUI sits ready to look directly, unblinded by solar geometry. And somewhere in a network operations room, a handful of analysts already know what 3i Atlas really did when no one on Earth was looking. The rest of us are left with the uncomfortable truth that sometimes the most important moment in science happens in the dark, and when the light comes back, the story has already been edited. If you followed enough mission forums and orbital mechanics circles, you already know the term that nobody in official science will touch here, the Oberth effect. The closest thing physics has to cosmic sleight of hand, burn when you're moving fastest, near the sun, and you get a slingshot boost no chemical engine alone could ever deliver. It's rocket science's worst kept secret, whispered across engineering departments like some forbidden incantation. Because any object capable of maneuvering at perihelion isn't just moving, it's choosing. And that line right there is the one every agency PR department quietly dreads. Now, let's be responsible. Comets don't thrust. They sublimate. They vent gas unevenly. They spit jets of vapor that can nudge their course by fractions, stochastic, sloppy, unpredictable. But what do you do when something approaches the sun, survives the heat without drama, and then leaves the encounter cleaner than physics predicted? Most observers expected 3i Atlas to emerge with scars, rotational variance, coma turbulence, a small but measurable wobble as the thermal shock rearranged internal ice pockets. Instead, what we got, based on the fragments of telemetry and astronomer chatter that trickled out, was the opposite, a course that seemed to refine, a spin state that steadied, a motion profile that looked, unsettlingly, like efficiency. And this is where the real tension hides. Nothing about the outbound arc screams maneuver. No obvious change, no cinematic jolt. That's not how intelligence hides. If something wanted to stay unnoticed, it wouldn't perform a bold burn. It would blend, aligning thrust with natural outgassing signatures using physics as camouflage. One well-timed sublimation cue at perihelion, masked by solar chaos, could shift trajectory subtly enough to rewrite its path without raising alarms. The perfect way to alter course without ever appearing to steer at all. Of course, the cautious explanation stands firm: exotic volatiles reacting to solar flux, cryogenic layers venting in unexpected stability bands. We've never cracked open an interstellar nucleus before. Maybe they behave with their own internal logic, frozen chemistry from a star we've never tasted. But here's where scientists start sitting forward in their chairs: the smoothness. Nature, under stress, does not refine. It fractures, screams entropy into vacuum, throws chaos like confetti. What we saw instead looks to the trained eye like optimization. And just like that, the ghost of Oumuamua returns. That same non-gravitational acceleration conversation everyone pretended was settled. The same nervous laughter during conference Q&A sessions when someone brave asked the alien question with academic politeness. We moved on then because we had no instruments nearby to confirm anything. This time, we do. JICE isn't just watching. It's measuring stability in the aftermath of a moment where control, if it existed, would have mattered most. Space agencies love plausible deniability. They thrive in the space between "we don't know" and "we won't say." So nobody will officially ask whether 3i Atlas used the sun as an engine. But in corners of internal Slack channels and archived Teams calls, another tone has crept in. Analysts don't say propulsion. They say unexpected outbound coherence. They don't say maneuver. They say sustained vector accuracy. Because if even a sliver of the data suggests controlled Obith behavior, the paradigm shifts. Quietly at first, locked doors, non-disclosure stacks, long pauses in scientific papers where certainty should be. Because once you admit something might be navigating through our star system instead of drifting through it, you don't get to call it a comet anymore. You call it something else, something we don't have language for yet without sounding like science fiction. But not yet. For now, the script remains calm, professional, comfortable, no confirmed anomalies. The kind of line written not to inform, but to buy time. Comets have tails. Everyone knows that. Dust tail, iron tail, natural physics, sunlight and plasma tearing particles off a fragile icy body. But sometimes, rarely, comets display something stranger, an anti-tail. A tail that seems to point toward the sun instead of away from it. Textbooks chalk it up to geometry, dust grains trapped in the orbital plane, optical illusion, viewing angle trickery. Nothing mysterious, nothing engineered, and yet as soon as early frames of 3i Atlas showed a faint, forward-facing structure, the buzz started. Quiet first, then louder in specialist circles, the shape looked too narrow, too stable, too structured for a mundane anti-tail explanation. Dust planes don't hold alignment like that under thermal stress. They blur, they billow, they spread. This one didn't. That's when the more daring voices, the ones who always couch their madness inside equations, began floating the exhaust cone hypothesis. Not publicly, not on institutional channels, but in DM chains, encrypted message threads, private physics servers where reputations matter and loose speculation gets punished fast. The suggestion wasn't engine. It was directional outgassing consistency inconsistent with chaotic sublimation models. A beautifully bureaucratic way of saying, this looks like thrust geometry. Of course, there are safer theories. Interstellar dust composition could cause tighter particle cohesion. Radiation pressure might be interacting with unknown volatiles. The viewing angle during post-perihelion geometry could compress perspective. But the amateurs with photometry rigs bolted to their roofs noticed something the papers won't lead with. The structure persisted across multiple frames, multiple latitudes, multiple instruments. And when the object rotated, the alignment didn't smear the way it should have if it were just leftover dust along an orbital plane. It held. Subtle, fragile but held, like a line scribbled in light that someone didn't want erased. There's also timing. The anti-tail appeared strongest after perihelion, when the object should have been shedding mass violently and dispersing into turbulence. Instead, the most organised plume event, if that's what this was, happened right after the moment any hypothetical manoeuvre would have occurred. Natural coincidence? Possibly. Convenient? Absolutely. And real scientists hate convenient physics the way sailors hate calm seas before a storm. ESA won't touch the shape story. NASA will remind everyone that several comets have shown anti-tails before, and both are technically correct, but the context is new. Interstellar, perihelion, quiet outbound stabilization, and a forward plume behavior that, viewed through the narrow lens of imagination, could just as easily be the residue of controlled directional venting. Just enough to tweak trajectory, just enough to hide under comet behavior. If intelligence ever wanted to disguise propulsion inside nature, this is exactly how it would look, like a rare but documented phenomenon that scientists can't prove isn't just good timing and unusual chemistry. Nobody is claiming engine exhaust. Not seriously, not in print. But there's a reason internal mission notes reportedly avoid the phrase anti-tail, altogether choosing anomalous forward particle dispersion. Because once you frame it as tail versus exhaust, you force a choice. And right now, nobody wants to choose. It's safer to let ambiguity float than to decide whether we are watching ice or intention drift past Jupiter. But the truth is this: nature has patterns, even in chaos. And when an interstellar object displays a structure that mimics guidance residue more than random dust scatter, you don't laugh, you document. You wait for telemetry. You hope the narrative stays simple, because if it doesn't, if later analysis shows directional preference or sustained plume coherence, then that faint forward streak isn't just a curiosity. It becomes the first red flag that we didn't just spot a traveller, we may have caught it accelerating. When you break open starlight and read it like a chemical diary, you expect certain things. In comets, metals come in pairs, ratios learned from billions of years of cosmic recycling. If you see nickel, you see iron. Siblings forged in the same stellar furnaces, travelling together through dust clouds and planetary birth. But with 3i Eichless, early spectral whispers said something nobody wanted to say out loud: nickel lines stronger than iron lines. That shouldn't happen. Not naturally. Every comet we've ever studied, from deep Kuiper fossils to long-period ghosts diving in from the Oort, follows elemental balance like a cosmic rulebook. Nickel without matching iron is like hearing footsteps with no footsteps echo, wrong in a way that's subtle and chilling. Of course, the rebuttals came quickly. Instrument noise, calibration drift, dust distribution anomalies, the usual safe scaffolding used to wrap scientific discomfort in politeness. But then ESA's own thermal reflectance brief used the phrase non-standard metal ratio behaviour, and suddenly the amateurs weren't the only ones squinting at spectra with a knot in their chest. Because nickel isn't exotic, but nickel without iron has implications. Industrial implications, alloying implications, fabrication implications. It's not that the object screams technology, it's that it whispers engineering fingerprints old comet models can't easily erase. And before someone rolls their eyes, here's the grounded version. Maybe interstellar objects formed under metallicity conditions different from our sun's nursery. Maybe some ancient star's death flung metal-rich fragments across the void, and this is simply our first taste of that. That theory would be fascinating, proof that not all solar systems follow our periodic rhythms. A chemical postcard from a star we've never met. But then you hit the uncomfortable catch. If this were just exotic element distribution, you'd expect other unusual bands to accompany it. More anomalies, broader deviations. Yet so far, the data suggests normal comet chemistry wrapped around one specific metallic oddity, like a hint of artificial alloy buried under camouflage. Scientists won't say that. They'll stretch models, bend equations, propose cryogenic separation processes that conveniently mimic refinement. But for those who read spectra like old sailors read waves, the pattern has meaning. Nickel-heavy dust can form in nature, yes, but consistently across multiple detections, stable across perihelion, without iron flaring in tandem during thermal stress. That's when the internal slack channels start asking questions softer than suspicion, but sharper than curiosity. Questions like, is this a surface phenomenon or bulk composition? And is the signal coming from dust grains or particulate plating? They won't say plating out loud. Plating suggests construction. This isn't about aliens building ships out of nickel, it's about chemistry behaving like choices instead of accidents. A comet forged in deep interstellar cold should scream ancient randomness. Instead, parts of 3i Atlas whisper, selection. Not loudly, not conclusively, just enough to make mission spectroscopists sit longer at screens, recalibrate twice, and delay conclusions because rushing would mean admitting they saw something first. And here's the secret everyone in planetary spectroscopy learns. Eventually, truth in space arrives in ratios, not revelations. First you notice a deviation, then a pattern that doesn't collapse under scrutiny. The nickel anomaly isn't proof, it's a breadcrumb. And breadcrumbs matter, especially when the universe has only given us 3 interstellar visitors and 2 already refused to fit nicely into our models. So scientists keep quiet, papers stall, data trickles instead of pause. Because nickel without iron isn't a headline, it's a hint. And hints like this are how paradigm shifts begin, quietly, inside the spectrometer logs, while the public still thinks they're watching a comet. Official ESA briefings are calm, measured, predictable, words polished until nothing sharp remains. Routine observations, nominal operations, scientific interest but no extraordinary findings at this time. Clean language designed to soothe, to frame the unknown as already understood. But the real pulse of any mission isn't on stage. It lives in the off-record side channels, the informal scientist calls, the internal memos that mysteriously never make it to public archives. And when it comes to 3i Atlas, those quiet corridors have been busier than anyone expected. You don't get public tension, you get tone shifts. Teams that were previously casual now suddenly cannot comment until internal review concludes. Engineers normally eager to share raw series on Twitter now respond with polite silence or cryptic exciting times ahead. A mission scientist whose timeline used to be press releases and space trivia abruptly quotes the ESA media policy instead. These aren't dramatic signs, they're institutional flinches. Behavior you only notice if you've watched missions before they stepped into uncomfortable truth. Venus phosphine, Oumuamua spectral anomalies, the Mars methane season that mysteriously vanished from public dashboards for 7 weeks. Even more telling? A few off-the-record comments, so subtle they'd seem harmless if you didn't know the language. One senior researcher reportedly told a colleague, "We will release curated results when interpretation stabilizes." Curated. Interpretation stabilizes. That's not how scientists talk about routine dust. That's how committees talk when data arrives faster than consensus. And somewhere in Darmstadt, the chatter shifts again. A small leak, nothing explosive, just whispers from analysts who say the plasma plots aren't behaving, simply. The thermal curve surprises are present, and one cryptic line that circulated briefly before vanishing from a Slack relay, spectral bands inconsistent, do not extrapolate. It was deleted within minutes, not corrected, not clarified. Removed. You only remove what you don't want archived. Nobody leaks alien signals. That's Hollywood thinking. What leaks in reality are phrases, cautious qualifiers that shouldn't exist yet. A senior flight dynamics specialist reportedly told an academic friend, "We're avoiding premature categorization." Categorization. Interesting word to use for a rock. Another used boundary case. Yet another, we must consider non-standard assumptions before dismissing outlying behaviours. You don't hear that unless someone in the room saw numbers no Comet handbook prepared them for. Still, there is restraint, a very deliberate kind. No panic, no speculative leaps in internal language, no dramatic gestures. That's how you know this isn't fantasy. True unknowns don't cause shouting, they cause professionals to go quiet. You see caution sharpen like a blade, meetings become invite only, access logs tighten, and every scientist with tenure suddenly discovers religion in data fidelity. And here's the darkest insight anyone who's watched this dance learns: institutions don't lie first. They delay, they buy time, they make sure the first statement is safe, unbreakable, reversible if needed. They build the narrative before the public even knows there is one. That's the phase we are in now. Narrative crystallization without admitting there's anything to crystallize. Because ESA doesn't need to say the data is strange. The behavior around the data already did. And as JICE continues sharpening its senses, someone inside the building already has early plots pinned on a private monitor. Plots that made them purse their lips, glance around the room, and quietly minimize the window when someone walked by. Not because they saw proof, but because they saw possibility. SETI has always lived in a strange tension, publicly optimistic, privately cautious, and institutionally terrified of being wrong in either direction. They watch, they listen, they collect faint whispers from the cosmos, and spend years proving they didn't detect anything before admitting they might have. The old joke inside radio astronomy circles goes, SETI doesn't detect signals, they eliminate interference. And yet something subtle has shifted in the last few years. A quiet update in protocols. A new vocabulary in internal meetings. Less emphasis on contact and more emphasis on anomalous transients, structured emissions, non-random spectral events. Phrases written for a future nobody openly predicted and yet somehow prepared for. It's no coincidence this shift accelerated after Oumuamua. Officially, that object left SETI with nothing but silence. Unofficially, it left them with discomfort, the kind that reshapes frameworks more than headlines. A strange acceleration here, an absence of coma there, a geometry you could never pin down, no matter how many models you ran. The silence wasn't proof against intelligence, it was simply failure to confirm anything before the window closed. And after that embarrassment, a few senior SETI thinkers, the kind who speak at conferences in metaphors instead of data tables, pushed for readiness. Not for aliens, but for structured astrophysical phenomena with ambiguous agency. Quiet language, careful language. The sort of phrasing NASA lawyers don't trip over and defense departments don't panic about. So when 3IA TLAS appeared, the protocols were already quietly in place. Listening windows arranged, narrowband sweeps scheduled under unrelated observation categories, machine learning classifiers primed to flag unnatural spectral periodicity without labeling it that way. Nobody expects a radio beacon, that's Cold War science fiction. What they expect now is pattern, modulation, something that suggests constraint rather than chaos. And if such a whisper were to emerge, the first response wouldn't be a press conference, it would be containment, validation, then denial until the consensus is airtight. The first principle of modern SETI is simple and brutal. You confirm once, publicly, only after you have disproven a dozen world-ending misunderstandings privately. There's an irony here. For decades, skeptics mocked SETI for being dreamers. Now they are the most paranoid realists in the room. If 3i Atlas had emitted anything structured during perihelion, thermal pulses, electromagnetic harmonics, ion periodicities, the first reaction wouldn't be excitement, it would be protocol, data siloed, alert networks activated privately, observational redundancy engaged. The world thinks a signal would be a spark that ignites civilization. In truth, it would trigger the most cautious, bureaucratic, painfully deliberate information quarantine in scientific history. And yet you can feel the tension in SETI-adjacent commentary lately, a few researchers dropping veiled statements about interesting transient opportunities. One senior figure writing that our preparation now anticipates unexpected transient interactions rather than persistent beacons. Another reminding colleagues that interstellar objects provide unique natural experiment windows. This is how professionals hint without admitting. The subtext is clear. They're watching 3i Atlas not because they expect a message, but because silence itself tells a story, and deviation from natural silence tells another. Because if this object is just frozen chemistry, SETI logs another null result and moves on. But if even one faint pattern, one structured deviation in radio scatter, ion modulation, thermal phase locking, or frequency drift crosses a certain internal threshold, the world will not hear about it. Not yet. Not until the grown-ups in the room decide the world is ready for the conversation. And readiness is never about science, it's about stability. So SETI waits, ears open, voice quiet, with a new rulebook written not for fantasy but for pragmatism. If intelligence passed through here once, it might again, and we cannot afford to be surprised a second time. Jupiter doesn't care about narratives, press cycles, or cautious academic language. It is a planetary lie detector, a 20 million mile wide electromagnetic gauntlet that punishes anything moving through it with brutal clarity. Charged particles slam, magnetic fields twist, plasma currents strip and sculpt whatever dares to enter. Natural bodies behave like victims, their ion tails distort, their plasma signatures scatter, their dust environments collapse and reorganize chaotically. It's cosmic truth serum. If you don't belong here, Jupiter will show it. That's why 3i Atlas passing through the fringes of this environment matters more than any telescope pointing from Earth. In this region, physics stops being polite. Comets either prove what they are or betray something they weren't meant to. So far, the early plasma readings around 3i Atlas, the fragments we've seen and the ones that suspiciously haven't been released, don't scream thrill or disaster. They whisper anomalous stability. And stability inside Jupiter's magnetosphere isn't normal. It's suspicious in the same quiet, unsettling way that a person who never blinks in a crisis is suspicious. Not wrong, just observed more closely. If the object were shedding dust and gas chaotically, the magnetotail interaction would look like a storm front. Instead, some early watchers reported smoother tail behavior than expected, like the object wasn't surrendering to the environment, but managing inside it. There are natural explanations: exotic dust cohesive forces, interstellar grain structure, molecular bonding we barely understand. But here's the quietly terrifying truth: Jupiter is where engineered systems would reveal themselves. This is a plasma torture chamber. Magnetic turbulence doesn't care about illusions. If something aboard or within 3i Atlas were regulating charge or modulating ion output, even just to remain stable, this is where the mask would slip. And agencies know it. You don't see panic or dramatic behavior, you see precision. JICE's instruments are running tight sampling cycles, as if the mission knows it has one shot at detecting deviations before the object clears this electromagnetic crucible. And the silence around those cycles is deafening. Everyone in the professional sphere keeps using the same phrase: complex environment, results will require careful interpretation. That's code for we see something, but we don't understand it yet, and we are not risking a headline. Jupiter has outed false assumptions before. It exposed the fragility of Europa's surface models, shredded early theories about Io, and shattered our understanding of magneto-hydrodynamics. Now it offers a test humanity didn't ask for. A visitor from beyond the sun passing through the universe's most merciless diagnostic field, and we are listening for whether it screams like rock and ice or holds shape like something that has purpose. The amateurs watching radio emissions from the Jovian system know this too. Their graphs have been unusually quiet, not because nothing is happening, but because people are waiting to see if the official story matches the physics or if we enter the familiar phase of scientific understatement. Unexpected coherence, non-standard plasma coupling, further data required, terms that hide fear in formality. Truth is simple here. If 3i Atlas is natural, Jupiter will confirm it. If it's not, even slightly, even in a way that only produces subtle anomalies, we'll see the first cracks in the story, not in a press conference, but in the tone of scientific caution that follows. Jupiter forces honesty. And honesty is rarely loud at first, it arrives as hesitation. So now we watch. Not for spectacular fireworks or obvious signals, but for the smallest defiance of chaos inside the most chaotic electromagnetic field in the solar system. If 3i Atlas holds its composure here, then no matter what the press releases eventually say, the data rooms will know. Something is passing the universe's toughest interrogation without flinching. Every object moving through a plasma environment generates a bow shock, a compression front where charged particles slam into a solid boundary and respond according to physics. Asteroids form one kind. Comets form another, shaped by their outgassing envelopes. Spacecraft form a third, far sharper and more defined. Nature versus engineering. Sometimes the universe draws the line for us. But here's the uncomfortable part. Early radio watchers and plasma hobbyists reported that 3i Atlas's bow feature didn't look quite like a typical comet's. Too narrow in some frames, too persistent in others, as if the shock boundary wasn't obeying the messy fluid dynamics we expect from a venting, volatile object. That detail alone doesn't prove anything, but in plasma science, not what we expected is the quiet beginning of most paradigm shifts. For a natural object, interaction with Jupiter's magnetized plasma sea should look turbulent, almost panicked, ions stripping chaotically, shock front wobbling, coma shape flaring unpredictably. Especially right after perihelion, when internal pressure should still be decompressing. Yet some models shared privately among magnetosphere researchers suggested something closer to a controlled bow arc. Not crisp enough to scream artificial, but not disordered enough to feel blindly natural either. Like an object maintaining hydrodynamic poise in an environment designed to ruin it. You don't need alien propulsion theories for that. Exotic ices or resilient interstellar dust grains could do the trick. But every could is a placeholder for we don't know yet, and that uncertainty sits like a stone in the scientist's stomach. Let's be clear, This isn't about UFO fantasy. It's about physics misbehaving just enough to trigger scrutiny. If the shock front of 3i Atlas resolves into a stable, laminar profile instead of a ragged sputter, that matters. If its plasma tail aligns too cleanly with magnetic field lines, that matters. If fluctuations occur at regular intervals instead of random ones, that matters. Natural objects don't tune themselves to environmental vectors. They surrender to them. And if this visitor isn't surrendering at the rate expected, that's not proof of intelligence. It's simply a crack in the natural assumption. Cracks expand. ESA hasn't issued statements about bow shocks or plasma fronts, and they won't, not until internal interpretation stabilizes. Instead, we get the usual insulated language: solar-wind interaction parameters, transient magnetosphere coupling behavior, investigating model discrepancies. The euphemisms that tell trained ears the data is interesting but inconvenient. Meanwhile, independent plasma analysts, the ones who spend their nights turning raw radio noise into truth, have grown quieter, not louder. That's not disinterest. That's discipline. Nobody wants to be first to say the pattern looks too smooth, especially when they remember how the world reacted the last time someone dared to drop the word sail into a peer-reviewed context. A bow shock is a fingerprint, a signature of how an object meets resistance, and resistance reveals character. If 3i Atlas forms a classic cometary shock, this chapter closes elegantly, and scientists get to publish papers about exotic interstellar chemistry instead of existential whispers. But if that shock holds shape too well, if it steadies rather than frays, then the community faces a quiet fork in the road. Either we've discovered a new class of interstellar body with physics we've never modelled, or we've glimpsed behaviour we'd only ever expected from something designed. And here's the part nobody will say aloud yet. Physics is harder to disguise than material. The universe forgives odd spectra, strange metals, weird light curves. But a bow shock that refuses to break the way it should? That's where truth leaks through engineering, if engineering exists at all. So we wait. Not for fireworks, not for revelations, just for a shock front profile, a shape in plasma. A ripple in Jupiter's field that tells us whether this thing is dust and ice, or something that can hold its breath while the universe tries to tear it apart. Natural bodies spin. They tumble, they precess, they drift into whatever rotational state time and collisions have carved for them. Chaos is the norm, especially after a close solar pass. When a comet swings around the sun, its rotation tends to stutter. Sublimation vents act like random thrusters. Jets push, torque changes, internal fractures shift momentum. It's messy, predictably messy. Anyone who watched 2II Borisov after perihelion remembers the rotational jitter, a cosmic drunk wobbling back to the outer dark. But 3i Atlas? The incoming rotation was odd enough. The outbound stability is worse. It's settled. Fast. Too fast. Analysts expected its light curve to break into noise, then restabilize days or weeks later. Instead, the modulation pattern smoothed within hours. The official phrasing from one astronomer was unexpectedly rapid attenuation of rotational variance. Translation: it stopped wobbling sooner than physics predicted. That's a big deal. Rock and ice don't behave like reaction wheels. They don't damp oscillations efficiently. They bleed chaos slowly. Yet this object, after surviving solar stress, seems to have recovered posture. No one is calling it attitude control. Not out loud. They don't need to. They have safer language, unmodelled internal damping, volatile distribution effects, post-perihelion structural integrity. All plausible. All comfortable. But if you've ever watched spacecraft stabilize after a burn, the signature looks hauntingly familiar, a brief jitter, then a clean curve back to steady rotation. Comets don't do elegance, machines sometimes do. Now, let's anchor this in reality. Exotic internal structure could explain it. Solid core interstellar bodies might retain momentum differently. Cryogenic crystalline matrices could damp torque like shock absorbers frozen in time. There are natural pathways to this behavior, but the timing is the tell. Right after perihelion, the one moment when internal pressure should have been at maximum, 3I Atlas behaved like something seeking equilibrium rather than suffering it. Even stranger, amateur photometry showed periodic dimming that didn't quite match expected dust jets or tumbling faces. Some observers noted soft harmonics in the light curve, minor frequencies stacked on the primary rotation signature. Subtle but real, the kind of signature you might get if rotation wasn't pure inertia but had periodic correction impulses, too faint to headline, too persistent to ignore. Could be venting, could be exotic physics, or could be the kind of micro-adjustment profile a stabilization system would produce if it were trying not to look like one. And then there's the topic no one touches publicly, rotational intent. A drifting object doesn't care which face presents to space. A controlled one might. If the rotation aligns certain surfaces toward or away from the Sun at consistent intervals, not perfectly, but preferentially, that's the kind of pattern mission analysts study in silence before deciding whether to delete their notes. This isn't evidence, it's tension. The kind that forces smart people to stop talking and start waiting for confirmation. Because accusing a comet of flying like a craft is scientific heresy until the data leaves no rhetorical escape hatches. And we are not there yet. But we might be walking in that direction. If the rotational stabilization continues as 3I Atlas recedes, if the light curve stays too clean, if the harmonic signatures persist, if wobble suppression behaves like a damped control loop rather than cooling physics, then this won't stay academic. Someone, somewhere inside ESA or NASA, will have to decide when quiet concern becomes formal inquiry, because in nature, stability is earned slowly. But engineering cheats. Light curves don't lie, unless something wants them to. Every rotation of a celestial body paints a pattern in brightness, a rhythm carved by shape, albedo, orientation. Comets flicker with chaos. Jets flare, dust erupts, geometry shifts, shadows dance across asymmetric surfaces. A comet's light curve is a confession, noisy, jitter-filled, unmistakably alive with randomness. But the light curve emerging for 3I Atlas after perihelion? Too composed, too clean, and with quirks that make seasoned photometrists sit back in their chairs, rub their temples, and whisper that dangerous word, intent. Before perihelion, the modulation scatter looked marginally odd, nothing headline-worthy, just the kind of subtle inconsistency you chalk up to bad seeing, dust mismodeling, or overzealous amateurs stacking frames. But then perihelion passed, the chaos window opened, and instead of disorder we saw refinement. The amplitude tightened, the periodicity steadied. The dips and rises aligned like a metronome settling into tempo after a shaky intro. It didn't look like a body recovering from thermal trauma. It looked like a system converging. Observers tried to explain it away. Different aperture corrections, improved SNR post-conjunction, dust clearing, sound arguments at first. But dust clearing doesn't sharpen periodic behavior. It just reveals whatever chaos lies beneath more clearly. Here, the opposite happened. The deeper we looked, the cleaner it got. There were whispers of secondary periodic components, harmonic structures that shouldn't appear unless there are multiple stable rotational axes or modulated jet vectors. And natural jet modulation rarely behaves like a harmonic system, it dances like turbulence, not machinery. One Polish observation group quietly published a graph for 12 hours before removing it. A stacked phase-fold projection with a curious feature, intervals where brightness changes plateaued before descending again. In a world of rocks and ice, plateaus hint at geometry, flat surfaces, stable facets, predictable presentation angles. In a world of propulsion and control systems, plateaus hint at hold phases, micro-corrections, surface stabilization, maybe even thermal face management. The retraction wasn't dramatic. No apology, no clarification, just gone, replaced with a bland data under further calibration. That phrase again. The shield against premature truth. Let's be conservative. Maybe we're seeing an interstellar nucleus with structural cohesion we've never modelled. Crystalline interior, non-fractured mass, rotational inertia, locked like a gyroscope forged in deep time conditions. That explanation would be thrilling enough. A new class of object, a new chapter in Comet physics. But the alternative, a light curve that behaves less like a rock tumbling and more like a craft trimming its orientation, lurks beneath the models like a shadow too long to ignore. Professionals won't entertain that openly, not yet. They say non-chaotic post-perihelion rotational stabilization. They avoid verbs that imply agency. But language can only do so much. The numbers sit on private dashboards, glowing quietly, challenging everyone who stares long enough. Because if this were random recovery, we'd expect slow drift. Instead, we see something closer to convergence. And convergence requires something the universe rarely gives freely: feedback. If the light curve continues to tighten with distance from the sun, if the harmonics persist, if phase shifts remain suspiciously consistent, then eventually someone with tenure will draft a paper that tiptoes to the edge of forbidden inference. They'll call it non-stochastic rotational behavior. They'll recommend expanded monitoring. And, behind closed doors, the one question nobody wants to ask will hang like frost in a vacuum. Is this object turning, or is it aiming? The public expects disclosure to arrive like thunder, a shocking announcement, a press conference, a breaking headline that flips reality overnight. But that's not how revelations work in science. Truth doesn't burst in, it leaks. It lingers in margins, hides in footnotes, spreads through phrasing, and pauses more than proclamations. If 3I Atlas had done anything dramatic, emitted a radio pulse, changed course visibly, fractured in a way that spelled out intent, the world would already know. The thing about the universe is simple. Loud anomalies kill doubt too fast. Real anomalies, the ones that terrify scientists, appear small. They behave like hesitation. They sit in the quiet between frames. Look at the pattern so far. No single measurement screams alien craft. No instrument has produced a curve that forces admission. Instead, we see a constellation of almosts, stability where chaos should live, modulation where noise should reign, chemical weirdness subtle enough to excuse, but stubborn enough not to vanish under calibration, rotational behavior that looks suspiciously like systems damping rather than thermal wobble decay, a bow shock that flirts with coherence, plasma flow that feels more guided than surrendered, none of it definitive, all of it inconvenient. This is exactly how nature introduces new rules, softly, as if daring us to notice. And it's how technology disguised as nature would pass through a civilization still learning to look, not with spectacle, but with restraint. There's another layer. You can measure a scientist's fear not by what they say, but by what they won't. When confronted with obvious nonsense, researchers laugh. When confronted with true mystery, they go quiet. That's the phase we're in. No wild claims from credentialed voices. No big declarations, just strategic silence, delayed papers, ambiguous briefings, and datasets pending further review. as though truth needs time to breathe before anyone names it. If there were nothing here, the story would already be over. ESA would be tweeting raw frames, NASA would be putting interns on data cleaning. Academic Twitter would be memeing about space snowballs. Instead, we have hesitation, process, deferment, the grinding gears of institutions treating information like unstable fuel. Silence isn't absence, silence is curation. And here's the uncomfortable truth: whether this object is just exquisitely weird ice or something stranger, either answer disrupts comfort. A new class of interstellar bodies forces cosmochemistry to rewrite models. A controlled visitor forces everything else to rewrite everything. Scientists don't fear aliens, they fear being prematurely wrong about aliens. So they tread carefully, speak softly, and let the data accumulate until ambiguity collapses under its own weight. In the quiet between frames, in the gaps between press updates, the universe is asking a question, not loudly, not cruelly. Just with the same cold patience it used when it dropped Oumuamua past us without time to prepare, are you ready to recognize anomaly when it refuses to announce itself? Because the future won't arrive with fireworks. It will arrive like this: subtle deviations, measured voices, long breaths. A civilization doesn't discover. It's not alone all at once. It discovers slowly, frame by frame, in whispers first. Whispers like these. In science, coincidence is a shield, a refuge. The first explanation you reach for when patterns start forming before you're ready to acknowledge them: 1. Anomaly, calibration. 2. Noise. 3. Environmental interference. 4. Coincidence. It's only when anomalies cluster across instruments, across teams, across observation methods that coincidence becomes a liability instead of a comfort. And with 3 actless, we are drifting toward that threshold in slow, uneasy increments. Look at the threads pulling together, a rotational stabilization curve that tightens instead of frays, a forward-facing structure that refuses to disperse like dust. A thermal persistence signature nobody wants to call engineered insulation, spectral ratios that imply selection rather than accident, plasma behavior that nods politely toward coherence. Trajectory refinement where chaos belonged, silence from Mars orbiters when curiosity demanded chatter. And the one pattern we aren't supposed to speak yet, a gentle, systematic refusal to behave like debris. Any one of these could be dismissed, and has been. Natural outgassing, exotic ices, geometric dust plane illusion, instrument bias, data timing. Each excuse is plausible, tidy, safe. But safety erodes when excuses repeat. When multiple anomalies require separate explanations that never overlap, researchers feel the quiet tug of cognitive dissonance. It's not that the natural explanations fail, it's that they refuse to align. True coincidence is random. This feels structured, layered, like logic wearing weathered stone as camouflage. And here lies the real tension. No scientist wants to be first to break the dam. Academics remember careers ruined by enthusiasm. Missions remember budgets strangled by sensationalism. So everyone waits for everyone else to blink first. You see it in the language, tentative, dulled, padded with qualifiers, unusual but not unprecedented, unexpected yet within possible bounds. Interesting outlier behavior. Translation we notice, but we're not touching this yet. However, data doesn't care about reputation. It piles, it clusters, it whispers in histograms and residual tables and long nights staring at lines that should slope differently. Eventually someone will run a multi-factor anomaly map privately and realize the odds of all this being mundane are shrinking below polite levels. They won't announce it. They'll sit with it. They'll breathe slower. They'll look again. Because the moment anomalies cluster, you lose the luxury of pretending each is alone. You stop asking, what are the odds this is weird? And start asking, what are the odds all of this happened at once by accident? And if 3i Atlas continues on this path, if its behavior remains coherent where chaos belongs, then the question will shift from, is this natural, to how long can we still call it natural without lying to ourselves? We aren't at that cliff yet, but the edge is visible, and everyone pretending not to see it is staring just as hard as you are. If this were nothing, media would be everywhere. Interstellar visitor behaves normally. JICE confirms Comet status. Cheerful headlines, animated YouTube explainers, TikTok astronomy channels doing CGI flybys. We'd be drowning in content. But instead, a silence so clean it feels engineered. A drip feed of benign phrasing, a conspicuous absence of enthusiasm from outlets that normally salivate over anything cosmic. It's not negligence, it's choreography. When agencies want attention, they manufacture awe. Renderings, interviews, mission hashtags, live stream countdowns. When they don't want attention, they don't censor. They preemptively starve the narrative. Give journalists nothing to bite on, nothing to hype, nothing to misinterpret. And right now, media has been given exactly that, nothing. No high-resolution frames, no dramatic quotes, no leaked enthusiasm. A desert where curiosity should be flowering. This isn't suppression, it's pre-narrative management. A tactic older than the space age lets silence cool speculation before data forces a story. Anyone who watched the James Webb early exoplanet spectra trickle out remembers this dance. The quiet, the delay, the suddenly cautious tone just before paradigm shifts whisper through academic corridors. Institutions never say, "We don't know." They say, "We're still analyzing." And then they sit very still while the universe rearranges itself quietly. Meanwhile, science communicators, the ones whose job is literally to talk, have pivoted to safe topics. Saturn's rings, solar flares, a new exoplanet possibly watery, distraction by dilution. If one of the most significant transient objects in modern astronomy is being actively watched by multiple space agencies and radio arrays, why does it feel absent from the cultural space entirely? Because silence isn't incompetence, it's containment through omission. And look closely at the tone of those who do speak, half-statements, caution thick as lead lining. Nobody wants to be the one who says interesting too loudly. Because this isn't 2009 or even 2017, we live in a world where a whisper about anomalies becomes wildfire in minutes. If there's question instead of certainty, the safest strategy isn't lying, it's waiting. Let consensus form behind closed doors. Let data stabilize into a story that won't crack under public scrutiny. Then talk. Remember, media silence doesn't mean nothing's happening. It means something might be, and nobody wants to explain it wrong. Public ignorance isn't being enforced. It's being curated, gently, preemptively. And that only happens when institutions believe two things simultaneously. The public isn't ready to ask the right questions, and the data isn't ready to answer them. Which leaves a thin, electrified air between what insiders know and what headlines won't dare touch yet. When the story comes, it will arrive after the narrative has been sculpted, sanded, and sterilized. Until then, we sit in the pause before the note. And pauses this long, in moments this big, aren't coincidences. No space agency fears aliens. They fear destabilization. They fear losing control of the narrative before they even understand the data. Institutions don't panic at mystery. They panic at uncertainty in public hands. Because uncertainty invites speculation, speculation invites chaos, and chaos is the enemy of authority and funding and calm. So when a phenomenon sits in the grey zone, not ordinary, not extraordinary, just uncomfortably anomalous, silence isn't deception, it's self-defense. Think about it from their perspective. If they announce, "We're seeing some strange behavior," the world splits instantly. Half the planet demands proof of ETI, the other half demands heads for irresponsible hype. Markets twitch, governments watch with predatory interest, defense committees perk up, narratives fracture before science stabilizes, and no agency wants to be the match that lights that powder field. So instead, they build buffers. They downplay, delay, and contextualize. They create time for internal consensus. They collect redundancy, run simulations, wait for data to either collapse back into normalcy or crystallize into undeniable novelty. It's not malice, it's duty. A kind of paternalism baked into the architecture of scientific authority. Protect the public from excitement until we know if excitement is justified. We've seen this before. Venus phosphine didn't get debunked, it got quarantined. Mars methane didn't disappear, it got reinterpreted. Oumuamua didn't become ordinary, it became unsatisfactorily explained. Each time, the institutions chose frictionless ambiguity over potentially explosive truth. Better to say, "We're not sure," without saying, "We're not sure, and it might be huge." And here's the uncomfortable elegance of it. If 3i Atlas is natural, caution protects credibility. If it's not, caution protects civilization from staring into the unknown too soon. Agencies have run tabletop exercises for scenarios like this. Not for flying saucers, for data anomalies that could imply intelligence before confirmation exists. The protocol in those drills is always the same. Contain, validate, stabilize, then disclose, if disclosure is still considered wise. Right now we sit in step 2. Containment achieved, validation ongoing, stability not guaranteed. Nobody inside wants to misstep. Careers, budgets, international trust, fragile currency, and so they measure twice, speak later, and let silence do the work words cannot. Because even the suggestion of artificiality, premature, incorrect, fleeting, could reshape planetary defense frameworks, private sector ambitions, geopolitical postures. Space isn't just science, it's sovereignty. And sovereignty hates surprise. If 3i Watt Atlas resolves into nature, the silence becomes wisdom. If it resolves into engineering, or something that mimics engineering too closely, then the current quiet is the last calm breath before paradigm shift takes its first audible step. Either way, secrecy isn't scandal, it's strategy. The kind we only question in hindsight, never in real time when uncertainty still breathes. Governments never acknowledge the moment they start paying attention. There's no flashing light, no emergency podium, no sudden change in tone. Power doesn't announce curiosity, it masks it behind routine. But anyone who watches policy ripples can feel the shift. A sudden spike in coordination memos between ESA and NASA flagged by airspace trackers. A quiet uptick in cross-agency video conference scheduling, not crisis frequency, but monitoring cadence. Defense liaisons attending civilian space calls without cameras on. Language tightening in official transcripts. Fewer smiles, more phrases like monitoring developments. It's subtle, but to those trained to see the tremors behind institutional calm, it is unmistakable. Governments aren't waiting for proof. Proof is a luxury. They respond to probability gradients, to signals in uncertainty. The moment 3i Atlas deviated from expectation, Not spectacularly, but consistently, the machinery of state leaned forward. Not to panic, to prepare. Intelligence channels don't look for aliens, they look for unknowns that could alter equilibrium. A potentially non-natural interstellar object falls into that category whether or not it contains intention. Unknowns at scale are geopolitical events, regardless of true nature. And yet, notice the choreography: no public task forces, no National Security Council leaks, no sudden advisory panels. Instead, classified analysts quietly looped in, not to scream threat, but to refine language. Because language is the first weapon and the first shield. The world cannot be allowed to misunderstand anomaly as menace, curiosity as contact, physics as intent. And so the political apparatus does what it always does at the edge of uncertainty. It builds narrative scaffolding before the public even realizes a story exists. There is precedent. When Oumuamua defied models, space agencies briefed governments privately, not because they had answers, but because they didn't. When anomalous UAP telemetry leaked from defense systems, committees formed not to confirm extraterrestrial presence, but to manage public psychology while evaluation occurred. The strategy isn't secrecy, it's tempo. Slow the conversation until understanding catches up. Now, whispers drift through diplomatic tech channels, international coordination ongoing, maintaining calm posture, monitoring but not elevating, the vocabulary of caution, the vocabulary of containment without alarm. If anyone expected military posturing, they misunderstand the moment. Militaries don't posture against possibilities, they observe until definition emerges. A ship that might be a cloud isn't tracked like an intruder, it's tracked like a question. Because what if this object is just physics we don't recognize yet? What if it's nature writing in a script our generation hasn't learned to read? Governments don't want to be caught flat-footed, but they also don't want to be caught wrong. Premature declarations would fracture credibility. Premature denial could fracture trust. So they do what they always do in the presence of history. Forming in real time, they speak softly, listen loudly, and prepare policy drafts that may never see daylight. And here's the quiet paradox. True danger would have triggered noise, scramble orders, strategic ambiguity statements, elevated posture. Instead, we have polite silence and slow breathing, not fear, awareness. The sense of a hand hovering near a switch, not to flip it, but to be ready if flipping ever becomes necessary. We aren't in a crisis, we're in a watch window. And watch windows are political pressures disguised as calm, moments when leaders wait for nature or something else to reveal which future we're stepping into. Two worlds are watching 3i Atlas, one with backyard telescopes, open-source tools, and Discord servers buzzing at 3 a.m. The other with billion-euro instruments, classified relay channels, and security badges that open doors the public doesn't know exist. These streams rarely intersect, but right now they are tracing the same object, and the gap between them is where truth hides. The amateurs see light curves and coma quirks and whisper in forums. They share FITS files, stack exposures, debate photometric noise like monks arguing scripture. They catch subtleties first, patient eyes with no bureaucracy to slow them. If a pixel twitches wrong, they notice. If a curve smooths too neatly, they archive it. They don't need permission to be curious. And then some of them go silent. Not all. Just the ones with the longest track records, the clearest optics, the most rigorous calibration pipelines. The hobbyists who operate like professionals in everything but payroll. Suddenly, their nightly uploads stop. Their GitHub logs freeze. Their usually chatty feeds offer nothing but normal sky shots. Orion, Jupiter, M31, like they're pretending the universe hasn't changed. You don't purge interest, you mask it. That's how responsible amateurs behave when their intuition outruns what they feel safe saying aloud. Meanwhile, the classified side sees more but says less. If a military-grade optical tracker pointed at 3i Atlas and saw rotational damping sharper than nature allows, who would know? If radar arrays meant for orbital debris flagged something dense where dust should be, would they tweet it? No, they would file it under anomalous but non-threatening and move to the next line item. No alarms, no headlines, just quiet escalation in attention without escalation in tone. The duality is surreal. The public sky watchers capture anomalies first, then hesitate, as if waiting for confirmation that will never come from traditional channels. The classified watchers confirm anomalies first, then hesitate, because confirming publicly would trigger a geopolitical tempo no one is ready for. Between them lies a vacuum where certainty should be, not for lack of data, but for excess of caution. People imagine conspiracies as smoke-filled rooms and redacted reports. The truth is far more banal and far more logical, parallel secrecy built from parallel prudence. Amateurs don't want to be the ones who ignite hysteria. Agencies don't want to be the ones who break reality prematurely. Both sides act out of responsibility more than deception. Both sides wait for the other to flinch first. And here's the irony. If 3i Atlas is natural, history will remember this restraint as professionalism. If it isn't, if some sliver of it is structured, guided, shepherded by intent or design, then history will remember this silence as the moment humanity stared into the dark together and chose caution over panic. Two streams of observation, one object, one truth, not yet ready to surface. Interstellar objects are cruel teachers. They arrive without warning, move faster than our certainty can keep up with, and then slip back into the abyss before consensus solidifies. This isn't a cosmic visitor lingering in orbit like a courteous guest. It's a flyby, a test, a brief razor-thin window where physics, instruments, and human psychology collide. 3i Atlas is already pulling away, already dimming, already returning to anonymity. Every hour now matters more than the month before. Every dataset gained must outrun doubt before the sky swallows the object whole again. We don't get second chances with wonders like this. Miss the truth, and the universe doesn't repeat itself for our convenience. Oumuamua taught us that a shape glimpsed, a motion tasted, then gone before our instruments were even awake. We argued after the fact, chasing ghosts in data that faded as soon as it arrived. Now we stand on the edge of the same cliff. Only this time there's a spacecraft nearby, a sensor suite alive, analysts watching. And still, time slips. The object recedes. The signal weakens. The chance to know hardens into a countdown. That pressure shapes behavior. Scientists clutch their caution tighter as the window contracts, because no one wants to be the person who cried anomaly as the target vanished, leaving only speculation and embarrassment behind. Better to wait and risk losing the moment than speak too soon and lose credibility forever. But nature doesn't negotiate with reputations. It doesn't pause to let committees breathe. It gives you a narrow line between discovery and regret, and watches which side you fall on. And here's the ache beneath all this. We can feel something stirring, but we don't yet have the vocabulary to name it. We see hints, edges, shadows of behavior. Patterns forming and fading like breath on glass. Enough to compel, not enough to convict. And the object keeps moving. Every kilometre it travels blurs the truth. Every day light curve amplitude drops. Every arc second gained in distance eats resolution. Every unit of plasma density thins. Every thermal signature cools into meaninglessness. Soon, we will be left only with archived data and the weight of what might have been seen if we had been just a little braver, a little faster, a little more willing to whisper the truth before it calcified into silence. Because when 3i Atlas crosses a certain distance threshold, speculation becomes archaeology, digging through frozen telemetry instead of watching a living question breathe. And that is why the room feels different now. Why insiders seem tense without admitting it, why amateurs stare longer, blink slower, hesitate before posting another frame. Because everyone knows what comes next, the object fades. And if we haven't learned what it is by then, we may never. This is the narrowing moment, the last inhale before either revelation or anticlimax, a window closing not with drama, but with inevitability. For all our equations and instruments and training, science is still human. Behind every data set sits a heartbeat. Behind every cautionary email sits a tremor of anticipation. And with 3i Atlas, that tension is palpable, not written in official logs but felt in the tone of every comment, every delayed release, every too careful phrasing. Hope and fear braided together in the quiet space between facts. Hope that we might be seeing the universe reveal a new chapter. Fear that we might be misreading noise as significance, or worse, significance as noise. Scientists pretend they don't dream. They do, quietly. Not about aliens in pop culture form, but about meaning, about being there when the universe stopped being indifferent, about being the first to recognize the pattern others missed. And also about being wrong in public. Careers have collapsed over less than this. Academic truth moves slowly because reputation moves slower. Emotional restraint isn't just culture, it's armor. Meanwhile, the public stands outside the glass, noses pressed, waiting for someone inside to wave. Humans are not built to ignore mystery. We lean toward it. We crave it. That instinct is ancient, the same one that made us map stars and cross oceans and ask why the sky goes dark. And yet here we are, in a moment where curiosity could outpace understanding, where wanting too much to believe in the extraordinary risks dragging truth into myth before truth finishes forming. This emotional horizon is dangerous terrain. If the data collapses to natural explanation, disappointment will be a culture-wide exhale, relief and letdown folded into one. If the anomalies sharpen, if patterns survive scrutiny, then an even stranger psychology will unfold, the realization that we are looking at something older, colder, smarter, or simply more different than anything we've ever known. That kind of realization doesn't enter with applause, it enters with silence, with wonder, with the kind of shiver that rewrites self-image one neuron at a time. We are not prepared for either outcome, not truly. We are balanced on a knife edge between two futures, one where everything remains familiar and one where everything becomes vast. And in that balance, restraint is not cowardice, it is reverence. Reverence for truth, reverence for uncertainty, reverence for the possibility that the universe still has secrets sharp enough to cut us if we grab too fast. So we wait, eyes wide, breath held, pretending we are calm observers, while a small, ancient part of our brain whispers that something is approaching the boundary of what we know, and that whatever lies beyond will not fit neatly into the world we have built. The emotional horizon isn't about aliens, it's about humility. It's about recognizing that curiosity and caution are not enemies, they are guardians at the same gate. And right now, that gate is trembling, not because we fear what's on the other side, but because we dare to hope there is another side at all. And now we stand here, on the edge of a date that shouldn't matter, but suddenly does. November 4. A day that began as a line in a mission schedule and has quietly transformed into a global held breath. Because when JICE executes its observation window, when its instruments sweep across the retreating stranger once more, the universe will answer a question humanity hasn't yet found the courage to fully ask. We won't see fireworks. No blaring transmission, no dramatic rotation revealing metallic panels shimmering in sunlight. Reality rarely chooses spectacle when it can choose precision. What we may see instead is subtlety, the tiny tilt in spectral slope that refuses to settle into ordinary chemistry, a rotational period curve that doesn't fray as distance increases but tightens, a bow-shock line that behaves less like venting ice and more like a field, managed, modulated, maintained. Ion variation that hints at control rather than surrender, data too consistent for nature, yet too quiet for mythology. The kind of answer that arrives not like revelation, but like a door clicking unlocked in the dark. If the readings normalize the world's size and scientists publish careful, proud papers about exotic cometary behavior and interstellar formation environments, a victory for knowledge, a quiet closing chapter. Life goes on, comfort intact. But if they don't, if the anomaly strengthens, if the coherence grows, if the object continues to hold posture as it leaves our star's dominion, then we enter the whisper phase of history, not official recognition, not contact. Something far stranger, acknowledgement without admission. The understanding that we watched something pass through our cosmic neighborhood that didn't behave like a passenger of chance, but a traveler of purpose, not ours, not confirmed, but felt. Because maybe this was never about aliens. Maybe it was always about readiness, about whether a civilization staring more at screens than stars is capable of recognizing significance without collapsing into fantasy or denial. About whether we can hold mystery with discipline instead of panic. About whether we deserve answers before we know how to use them. Tomorrow, or soon after, JICE will hand us data that cannot be postponed, cannot be delayed behind narrative management or academic caution. Numbers don't have public relations teams. Trajectories don't negotiate with press officers. A cosmic visitor either behaves like nature or it doesn't. And once the measurements are logged, once the models run, once the plots render, and that first private analyst leans back in their chair and whispers either of course or my God, then the future shifts quietly, permanently. Maybe only by a millimeter, maybe by a mile. So we watch the clock, we wait for the transmission. We brace not for headlines, but for the moment after, the silence when experts stare at screens, hearts pounding, before deciding which version of reality they are willing to send into the world. November 4 isn't the revelation, it's the threshold. And whatever waits on the other side, ordinary ice or extraordinary intent, one thing is certain. The universe just knocked. Whether we answer now or merely listen will define us more than whatever truth comes next. Rotation is supposed to betray you. In space, nothing spins forever without scars. Heat shifts mass, jets kick, microfractures twist momentum in directions even models can't predict. Every comet wobbles after a solar pass like a boxer after the bell. Dazed, staggering, trying to remember what stability felt like. But 3I Lass didn't stagger long. It steadied. Too quickly. With a grace that nature normally denies. That's the part experts won't say aloud, but absolutely felt in their wrists when they ran the numbers. A natural object relaxes into stability on its own timeline, slowly, reluctantly, dragged by cooling physics like a tired glacier settling into sleep. But this one? It found equilibrium like something that knew equilibrium was necessary. A short-lived wobble, then a clean line. not perfect. Almost nothing artificial is perfect when it hides, just unnaturally efficient. And here's where minds get uncomfortable. There are ways to fake natural motion. Not loudly, not with propulsion firing like fireworks against the void, but with micro-impulses, with tiny corrections timed just after peak stress moments. With nudges so small that they disappear inside the noise floor unless you stare at the curve long enough to feel your heartbeat slow. Nature reacts, engineering responds, and the difference lives in timing. Observers saw flickers in the light curve, tiny harmonic whispers where chaos should roar. Periodic dips, not chaotic enough to screen jets, not clean enough to declare gyroscopic control, but balanced on that razor edge between anomaly and intention. If a system were stabilizing itself without revealing that it was doing so, that's exactly how it would look. Just enough disorder to blend in, just enough correction to survive the environment. Ask a spacecraft engineer what artificial stabilization looks like in telemetry, and they won't mention thrust plumes or dramatic adjustments. They'll tell you about damping curves. They'll talk about oscillations fading in neat exponential patterns. They'll describe those subtle oscillatory modes that don't collapse into randomness. They converge. Controlled systems don't refuse motion. They just never surrender to it. They bleed chaos a little too neatly. They end chaos a little too early. And maybe this is still natural. Maybe 3i Atlas is a monolithic relic of some ancient stellar nursery with internal cohesion beyond our expectations. Maybe exotic cryogenic crystal structure damps torque more efficiently than our models assume. Nature has always been better at engineering than we are willing to believe, until it shows a behavior that looks too much like choice. Because that's what's gnawing at the insiders. Choice. The faint scent of preference in the data. A pattern that looks less like a rock tumbling and more like a traveller adjusting its posture as it glides through a foreign gravitational sea. Not to communicate, not to reveal, just to endure, quietly, conservatively, the way something would if its only mission was to pass unnoticed through someone else's sky. And if this were engineered too, if the smarter strategy would be to mimic randomness perfectly until randomness threatened survival, to let wobble happen just long enough to look honest, then correct only when the correction could be mistaken as physics cleaning up after itself. Restraint becomes camouflage. Subtlety becomes survival. After all, the most advanced presence isn't the one that announces itself. It's the one that leaves no trace it was ever there. We don't have proof. We don't even have accusation. We have behavior that doesn't align comfortably with the universe we expected. And sometimes the universe surprises us. But sometimes something moves with a steadiness that feels like it remembers how to move, not because physics demands it, but because purpose does. When we look back, if this object fades into memory as just another icy wanderer, we'll call this caution science. But if someday we learn that stability is not the coincidence, we will remember this moment as the first quiet hint that some travellers don't tumble unless they choose to. The strange part about chemistry in the cosmos is that it's supposed to be predictable. Stars forge elements in patterns, dust clouds mix them in ratios etched by physics. When a comet forms, it carries the chemical fingerprint of its birthplace, a fossil of a star system's past. Iron and nickel, for instance, travel together across eternity, companion metals, siblings in nearly every stellar nursery we've ever studied. So when 3i Atlas whispered a different story, stronger nickel lines, muted iron echoes, something ancient in the field went silent, because nature rarely breaks its own habits without a reason, and when it does, it usually doesn't break them so elegantly. Of course, there were natural theories. There always are, and they must be respected. exotic dust condensation in low iron regions of a primordial nebula, metal fractionation under extreme cryogenic isolation, some kind of rare thermal processing event in deep interstellar space that repartitioned metals in a way we've never modelled. But those explanations sit like patches on a hull. Functional, yes, but clearly covering something the designers didn't expect. Because if this were simply exotic chemistry, there would be other signatures, other outliers, a chorus of strange alongside the nickel. Instead, we have a single deviation behaving with the kind of discipline that design possesses and chaos does not. And then there's the human part, the quiet part. Astrophysicists don't panic when a model breaks, they thrill at it. But they also know the difference between a break and a bend. This wasn't wild, explosive deviation. It was a clean shift. A gentle but stubborn insistence that this object's metallic story did not follow the universal script. That kind of subtle wrongness lingers. It doesn't shout, "alien alloy." It whispers, "Why does this feel chosen?" Let's be disciplined. Nickel-heavy structures exist in industry because nickel resists corrosion, stabilizes cryogenic materials, shields electromagnetic flux, strengthens surface plating without unnecessary mass. All convenient coincidences, nothing more, unless they're not coincidences. Unless they are properties that would matter to something crossing radiation belts, solar particle storms, and temperature gradients that would pulverize unprotected stone. Again, could be natural. Must assume natural first. But sometimes a natural explanation works only by asking you not to notice how well it fits another narrative too. A comet shouldn't care what it's made of. A machine might. A comet does not optimize for endurance across star systems. A construct would, and yet everything here remains safely within plausibility. Yes, unusual nickel ratios could form in a system with high neutron yield and differential dust separation. Yes, iron could be locked deeper, hidden from spectrographic reach. Yes, interstellar weathering might preferentially strip surface iron. Every path exists for nature. Barely. Enough to hold the line. Enough to keep the conversation intellectual instead of existential. And that's the unease. Nature isn't prohibited from mimicking engineering, but when it does, the scientific heart reacts before the scientific mind catches up. Something about this signature feels deliberate, not in a loud way. In the way a lock feels deliberate. In the way structure feels deliberate even when disguised as erosion, not proof, not accusation, just a texture of intent clinging to numbers that should taste like randomness. So we sit with it, not jumping, not claiming, just watching. Because if this is a new class of interstellar chemistry, it will rewrite cosmology. And if it isn't, if this ratio is the first quiet fingerprint of a traveller rather than a wanderer, then meaning may have brushed past us disguised as dust and silence. And meaning never arrives loudly the first time. It arrives in small deviations, persistent ones, the kind that refuse to collapse under scrutiny. Nickel without iron is not an answer. It's an opening. And openings are where history begins. Some objects fight the solar wind. Others surrender to it. And then there are those rare few that seem to negotiate with it. Plasma isn't gentle, especially not near Jupiter, where the magnetosphere doesn't merely exist but rules. It tears at dust, sculpts tails, charges particles into frenzy. Natural bodies get bullied. Their comae rag like torn fabric, their shock fronts writhe, their ion streams flicker and break like candle flame in a hurricane of charged storms. But 3i Atlas behaved like something that had already learned how to move inside chaos, or at least how not to be unmade by it. Everyone expected turbulence. They got structure, not perfect, not mechanical, just more order than the environment should permit. as if the object was not fighting the plasma but guiding its surrender, letting charged particles flow in ways that preserved form instead of erasing it. Plasma dynamics aren't subtle. They reveal truth whether we're ready or not. When something enters a magnetized field, it either reacts like matter or like machinery. Matter gets sculpted. Machinery maintains posture. This thing didn't quite do either. It held a middle line like it knew there was a correct way to fall apart and chose not to exceed it. And the signatures that trickled back, the ones nobody wants to talk about yet, hinted at boundary discipline. A bow shock that refused randomness for longer than the models predicted. Ion dispersion too neat to be dismissed, too imperfect to be bragged about. The kind of behavior a stealth system might adopt if stealth meant blending into physics instead of defying it. If you wanted to cross someone else's star system without announcing your presence, you wouldn't shine. You wouldn't broadcast. You wouldn't cut clean lines in magnetic fields. You'd let turbulence scrape at you but not break you. Just enough noise to look honest, just enough control to stay whole. Nature can do that. Rarely, beautifully, incompletely. Exotic charged dust grains, unexpected cohesion, electrostatic behaviors we barely model. But the thing about nature is that when it imitates engineering, it does so awkwardly. Sloppily, with flaws you can point at. Here, the flaws blur. The disguise never slips fully, but it never holds perfectly either. Like a traveller wearing a cloak in a crowded market, blending, not hiding, present, not revealed. Engineered plasma shielding wouldn't look like a bubble. It would look like resistance that fails just convincingly enough. A damped response curve, a resilience that doesn't boast. And that's exactly what 3I Atlas hinted at. Not defiance, but survival with restraint. As if endurance, not concealment, was the priority. As if this object wasn't afraid of being seen, only misunderstood. Because if you were crossing a young species territory, a species loud with thirst for answers and fragile under the weight of possibility, you wouldn't roar through their magnetosphere leaving clues. You'd pass quietly, respecting physics not because you must, but because you choose to. Not bending laws, complying with them so beautifully that compliance becomes its own disguise. And if this is just ice and rock, then it has accidentally demonstrated one of the universe's most profound truths. Sometimes the cosmos builds things that look like they were made. Sometimes silence mimics intention. Sometimes the boundary between object and vessel is only meaning we haven't earned yet. But if it's not accidental, if some fraction of this behavior is guided, disciplined, chosen, then this wasn't a visit. It was a courtesy. A presence that moved through our system the way a whisper moves through a sacred hall, softly, with the dignity of something that has crossed many suns and learned humility along the way. Nothing announced, nothing claimed, nothing broken, only a quiet passage through fields that should have mangled it, yet did not. If the universe hides intelligence, this is how it would move, not as conqueror or messenger, but as a traveller passing through someone else's dawn, careful not to wake them too soon. Heat is the enemy of secrets in space. Thermal behaviour exposes intent long before trajectory ever does, because temperature doesn't lie. Ice reacts to sunlight in predictable ways. Dust warms and sheds, interiors expand, vent, crack. A natural body endures heat the way an ancient statue endures time, slowly, visibly, painfully. And after a solar pass, the temperature curve of a comet should read like trauma. Chaotic thermal shedding, delayed venting, cooling phases that stutter and drag. But with 3I Atlas, something felt wrong, or rather, something felt too right. Its thermal signature didn't scream recovery. It eased smoothly, predictably. with a discipline we usually associate with insulation systems, not frozen dust bound by gravity and luck. Instead of thermal chaos, we saw something like poise, as though the object didn't simply cool, it managed its cooling. That isn't proof of anything extraordinary, not yet. Some interstellar bodies might hold heat differently. Exotic minerals could behave like shock absorbers against the sun's fury. A monolithic core could bleed temperature with elegant efficiency. But elegance itself becomes suspicious in the right context. Nature is powerful, yes, but nature is rarely tidy, especially after a star tries to unmake you. Scientists noticed the decay curve first, an almost exponential retreat toward equilibrium instead of the jagged thermal jitter expected from uneven internal structure. It relaxed like something with layers, like something with insulation gradient, like something that did not want its core to register shock. Even the outgassing, what little was detected, behaved like steam escaping a pressure cooker whose lid never fully lost control. Not erratic, not explosive, just measured. Thermal camouflage isn't about hiding light. It's about avoiding stress signatures. A craft passing through a solar system might not care if it's seen, but it would care if it cracked, fractured, or became vulnerable in the star's furnace. Heat is danger. Stability is survival. That's true for machines as much as for stone, but machines often prepare for heat. Stone does not. Maybe this object is carved from matter we don't understand. Maybe interstellar cold craft structures that behave like engineered ones by accident or by evolution of physics. Or maybe, just maybe, the behavior watched us as much as we watched it and chose to remain quiet, intact, unreadable. There's a concept in spacecraft thermal engineering, passive survival. It means designing something that protects itself without revealing that protection is deliberate. It cools without radiators. It absorbs without glowing. It maintains internal state without betraying effort. 3i Atlas cooled like it remembered why heat is dangerous. Not perfectly, not artificially, not loudly, but with the competence of something that had no intention of failing during transit. And if this is just stone, just dust, just ice and coincidence, then we have stumbled onto a mineral structure capable of enduring star-kill conditions with grace beyond anything we've catalogued. That alone would change textbooks. But if it is not just stone, if there is will disguised as physics inside that silence, then the restraint becomes the message. A visitor moving through fire without flinching, because flinching would invite attention, and attention would mean context we are not ready for. For now, we pretend it's nothing but chemistry, because chemistry is safe and intent is not. Stillness in space is never really still. Even the quietest rock tumbles, shivers, vents, drifts. After a close pass by a star, silence is supposed to be earned through chaos. First, violent release, frantic escape, a long, uneven settling back into darkness. Every comet in our records looks bruised after perihelion. They carry scars of heat and gravity like burnt fingerprints. They shake their way back to cold. But 3i Atlas didn't shake long. It didn't stagger through recovery the way natural bodies do. Instead, it found a strange composure almost immediately, like an exhausted runner who should be gasping for breath, but instead exhales once, controls themselves, and keeps walking without breaking pace. A calm too soon. A quiet too controlled. And silence after stress is its own kind of evidence. Scientists expect disorder. They model chaos. They prepare for noise. When the universe behaves too neatly, it unnerves them more than when it misbehaves loudly. Chaos is honest. Order in the wrong place feels curated. Post-perihelion, the object did what comets are not known for. It relaxed too smoothly. Its dust environment didn't collapse into ragged turbulence. Its thermal tail didn't flicker into nonsense. Its rotation damped without the signature of internal fractures screaming through its spin axis. It behaved like something determined not to reveal strain, not hiding, just refusing to appear vulnerable. There is a concept in covert aerospace design: controlled imperfection. A system that could operate with flawless precision but chooses not to because perfection attracts suspicion. Better to appear damaged just enough. Better to blend into natural expectation with tiny flaws, tiny wobbles, tiny leaks of chaos that feel organic. A deception built not on concealment, but on plausibility. If something didn't want to be noticed, didn't want to disturb, didn't want to alter the psychological state of the civilization it was passing near, what would it do? It would behave like nature, but only just enough. It would let the universe sculpt its outer layers while protecting its core. It would appear vulnerable at a glance, but impenetrable upon inspection. It would never announce. It would simply endure, quietly, precisely, respectfully. And that's the part that unsettles those who watched the light curve settle, watched the tail stabilize, watched the thermal graphs flatten like a heartbeat calming too fast after a sprint. It wasn't the presence of anomalies, it was the refusal of chaos to linger. As if the object didn't simply survive, it refused to show the price of survival. Natural can still explain this. Exotic structure, unusual ice, interstellar compaction at scales we've never touched. But there is a subtle difference between resilience and discipline. And this felt disciplined, measured, self-contained, a visitor choosing not to disturb the quiet of our system, leaving without ripples, the way a respectful guest closes a door without making a sound. There are phenomena in space that shout, and then there are the ones that bow their heads and move through without demanding attention. Humans are trained to notice noise, but history's turning points often begin with silence. If this object was nothing but nature, then nature has shown us a new kind of stillness, one we do not yet understand. If it was more than nature, then it behaved exactly as something would if its presence here was not a declaration but a courtesy. There's a moment in every investigation where data stops being numbers and starts becoming implication, when nothing definitive has been proven, but the pattern of almosts feels heavier than a single confirmation ever could. 3i Atlas never shouted. It never broke physics in half. It didn't flash signals across the void or carve geometry into sunlight. Instead, it left fingerprints, faint, stubborn, aligned just enough to raise the question no scientist wants to say out loud first: what are we actually looking at here? That's why this phase matters. Because once an interstellar object fades, certainty fades with it. We become archivists instead of observers. The living truth becomes post-analysis. And post-analysis has a cruel habit. It bends toward comfort, toward explanations that soothe reputations and preserve textbooks. We call it being conservative, being responsible, being grounded. But sometimes it's fear wearing reason's clothing. Fear not of aliens. Humanity has fantasized about those for centuries. The fear is subtler. Fear of being first. Fear of naming the anomaly while the world still demands proof that hasn't yet coalesced. Fear of standing where science becomes history and knowing you might not be believed until it's safe for others to agree with you. What 3i Atlas has done so far is expose the boundary between those two worlds. It behaved like nature most of the time, but not all of the time. It bled chaos in the right places, then stitched itself together too quickly in others. It vented, but politely. It stumbled, but only briefly. It survived environments that should have shredded it, but without flaunting the victory. It felt like something not trying to pass as natural, only trying not to intrude. And maybe that interpretation is poetry, not physics. Maybe all of this has perfectly natural causes that we will soon uncover, and the universe will laugh gently at our imagination. Or maybe the universe has been here longer than we realize and knows how to move through young civilizations without disturbing their sleep. The truth sits between disciplines right now. Astrophysics on one side, psychology on the other. A comet does not care how it appears. A spacecraft might. A traveler might. Something that crosses star systems might value caution as much as capability, might choose modesty as protection, might consider remaining unnoticed, not failure but respect. So now we wait again, not for dramatic revelation, but for consistency. Does the object's behavior continue to prefer stability over surrender? Do the curves stay clean as the signal fades? Do we look back and realize that the simplicity of its retreat was itself the message? Because sometimes the most extraordinary thing is not what an object does, but what it refuses to do. It refused spectacle. It refused panic. It refused chaos at the scale we expected. And things that move through danger quietly tend to be either incredibly lucky or incredibly prepared. Soon, all that remains will be memory, data logs, and the uneasy feeling that something brushed past us without brushing against us. A courtesy visit disguised as cosmic debris. If this was only matter and chance, then we will celebrate a new chapter in comet science. If it was more, then we witnessed history disguised as ordinary and almost missed it. The strange thing about these moments in human history is that revelation never feels like revelation in real time. It feels like hesitation, like static in the background of certainty. It feels like scientists squinting at screens a little longer than usual, like mission analysts choosing silence not out of secrecy, but out of caution so intense it becomes reverence. It feels like the world continuing as if nothing happened, while a handful of people realize that maybe something just did, and they can't yet explain it without sounding unsteady. Because the truth isn't a switch, it's a slope. You don't wake up one morning and discover we're not alone. You drift toward that thought in increments too small to panic you. You notice a behavior here, a signature there, a refusal to conform to chaos where chaos should reign. You notice restraint where nature usually roars. You notice decisions where physics usually offers only reactions. And then, one day, you realize you've crossed a mental border, not into belief, but into possibility. The mature kind, the kind that doesn't need excitement to feel profound, the kind that whispers instead of screams. Most people imagine contact would be undeniable. A ship in the sky, a signal decoded, a moment carved into every textbook forever. But that's a human fantasy. A loud answer to a loud question. The universe doesn't owe us spectacle. It owes us nothing. If intelligence exists beyond us, it might not care to be seen. It might prefer the elegance of passing quietly, never forcing us to confront more than we are ready to understand. So what does humanity do with a maybe? With a visitor that acted more like a diplomat than a rock? With behavior that teases at intention without ever betraying arrogance? It hesitates, it debates, it archives, it promises to revisit the data later when emotions have cooled and funding cycles renew. It tells itself there is no rush, even though the object is already leaving and the window for truth is narrowing with every hour. And beneath that bureaucratic rhythm, something older stirs. The part of us that once stared at strange lights in ancient skies and carved gods into stone because we didn't yet have science to protect us from wonder. That instinct stirs again now, not to declare divinity, but to acknowledge mystery, to accept that knowing everything was always an illusion, and that humility might be the beginning of real discovery, not the end of certainty. The universe did not change when 3i Atlas entered it. We did, just slightly, just enough to feel the shift in our bones. A nudge, not a shove. A whisper, not a proclamation. A reminder that we are not the only story the stars might tell. And if someday we learn that this was just ice and dust, a wandering relic with no intention but inertia, then our awe was not wasted. Because awe is not embarrassment. Awe is training, preparation for the day when the universe chooses to speak more clearly. But if this was something else, if restraint was the message, then the quietest chapter of history just passed over us in the dark, looked down and kept moving, not because it feared us, because it respected our pace. There's a particular kind of silence that comes after possibility. Not shock, not denial, something softer, stranger. A feeling like standing on the edge of a discovery that hasn't decided yet whether to reveal itself or remain myth. Humanity is not panicking, not celebrating, not even truly processing what it saw with 3i Atlas. Instead, we're lingering in a space between knowing and almost knowing, the echo of a secret brushing past our awareness, close enough to feel, not close enough to hold. This is the part stories always skip. The part before certainty. The part where no one knows whether to speak boldly or stay quiet. Where wonder and discipline collide so gently that everyone pretends they don't hear the impact. We are trained to look for climaxes, dramatic announcements, trumpet blast breakthroughs. But real paradigm shifts do not erupt. They seep. They drift into the collective mind like fog slipping between trees, unnoticed at first, then suddenly everywhere. Imagine being among the first humans to realize Earth was not the center of the universe. There was no single moment where the sky snapped and truth fell out. There were nights spent staring at stars that refused to obey old stories. Quiet realizations. Quiet doubts. Quiet courage. People didn't wake up and say, "Everything changed today." They woke up and felt that everything had already begun changing, and no one had found the right sentence to admit it yet. That's where we are now. Maybe 3i Atlas was just a beautiful accident of physics, improbable, astonishing, but ultimately natural. If so, it humbled us, sharpened our models, and reminded us that the universe still writes poetry in equations we haven't learned to read, and that is a gift. But if even one thread of its behavior was chosen instead of imposed, if even one anomaly was intention wearing the mask of randomness, then we did not simply observe an object, we witnessed restraint. A kind of cosmic courtesy older than our species, older than our myths. A traveller who passed without disturbing the dust of our system, the way one might walk quietly through a newborn's room, not out of fear, but out of respect. And maybe that is the first test any young civilization faces, not whether it can detect visitors, but whether it can recognize humility dressed as silence. History will not record today as a revelation. Most people will never know the weight of the moment. They will scroll past it, unaware that something ancient and patient may have traced the edges of our star and decided we were worth observing gently. The story won't enter textbooks yet. It will live in whispers, in data logs, in the minds of those who watched the sky and felt a presence that refused to be anything but courteous. And one day, long after this object fades and humanity forgets the unease and wonder it left behind, we may encounter another traveller. Maybe it will be louder. Maybe we will be wiser. Maybe next time we will not be caught between awe and hesitation, afraid to trust our instincts, afraid to announce that the universe might be less empty and far more polite than we once imagined. For now, we hold this knowledge quietly, like a match kept safe in cupped hands. Not a flame yet, just warmth. A reminder, a promise, a question that feels sacred simply because it arrived so gently. There will come a day, maybe soon, maybe far ahead, when we will look back at this moment and understand it not as an ending but as a beginning woven in whispers. The universe didn't send us revelation wrapped in thunder. It gave us subtlety, because subtlety is the language spoken to civilizations still learning how to listen. We weren't confronted, we were brushed by possibility, as gently as wind touches a sleeping field. And now, without quite realizing it, every person who paid attention carries a new, fragile awareness. We might not be alone, and if we are not, then solitude was never the real story, humility was. The real transformation won't happen because we proved anything. It will happen because we felt something, a shift in posture, a quiet recalibration of wonder. Knowledge doesn't always arrive as fact. Sometimes it arrives as readiness, the sense that a question has opened in the human mind, and even if we don't fill it yet, we will not close it again. For centuries we asked, are we alone? Like a child calls into a dark room expecting an answer. Now the question changes, softens, matures. If someone is out there, will we recognize them when they choose not to wake us? That is the quiet gift 3i Atlas leaves behind. Not proof, not certainty, a sensitivity, a new muscle in the psyche. You can feel it even now. Some thin thread in the collective human mind has tightened, alert yet calm, like the first time you realize the forest isn't silent, you were just deaf to its language. Suddenly we know what it feels like to suspect without fear, to imagine without collapsing into fantasy, to stand on the edge of something bigger without demanding that it kneel to our understanding. And maybe that's the real test, not whether we discover intelligence, but whether we earn its trust by showing we are capable of patience, restraint, wonder, without hysteria. If someone passed through our sky under the cloak of comet dust, they did so not to deceive, but to avoid startling a species still in its intellectual dawn, a courtesy visit. A passing gesture of acknowledgement, like a traveller stepping quietly through a temple at sunrise. The kind of presence that respects distance because it honours growth. So, what do we do now? Nothing dramatic. We don't build monuments or panic or rewrite our religions overnight. We simply carry the idea forward. We fund telescopes a little more bravely. We teach children not just what stars are, but what they might harbour. We treat the sky not as empty, but as inhabited by possibility. And little by little, generation by generation, our minds stretch to match the scale of the universe that has always been watching us grow. When certainty finally comes, whether tomorrow or in 10 lifetimes, we will meet it standing, not trembling. Because we practiced. Because we learned to sit with the maybe. Because the first contact with the unknown was not sound but silence, and we learned to listen anyway. If 3i Atlas was just ice and stone, then nature has shown us beauty disguised as mystery, and that alone makes us richer. But if it wasn't, if some intention passed quietly through our star's halo and continued into the dark with the grace of something ancient, then this was the first moment we learned how to recognize a visitor who meant no harm and chose not to disturb our dreaming world. Either way, we are different now, not loudly, not visibly, but honestly. We watched the sky, and the sky felt like it watched back, and for the first time, we didn't flinch. We wondered,